prerequisites usually when we're taking the bash course on that website is to take Introduction to Linux OS, which is another course that I teach. Because everything that we learn in there kind of builds into what we're talking about in this workshop, but not a big deal. We can talk about, like I said, anything you're not sure about, we can go over in this workshop. No big deal. So here's kind of the overview for today. So we're going to talk about the shell script fundamentals, the syntax overview, which is super important in Linux in general. It's just how you type things, including spaces, capital, everything. Syntax is important. And then we're going to go over some examples. And then depending on if we have time, we'll actually go over some more advanced kind of concepts in scripting. And then we'll take a break at like 11:30, 12, whatever we feel like, when we need to get up, grab some food, we can talk about that, but we'll take a break as well. So we're going to talk about the fundamentals real quick. So in Unix or Linux, shell script is a human readable text file containing a group of commands that can also be manually executed one by one at the Unix operating system command prompt. So scripting is really no different than just typing in commands on the Linux command line. So the shell is where we type the commands in, and the shell interacts with the kernel on the machine. And the kernel is what tells the machine and the hardware to actually do stuff. So when we're typing in commands on the terminal, that's really kind of what scripting is. It's just when we write a script, it's a very long set of commands. So these are often kept in a file, which is called a script. And just like I said, often, you don't want to type all these commands out on the line. So you open up this script and you type all the commands out on there. And then each time you want to perform that, you can execute it on the computer, So you don't want to have to type these commands out every time. If you're doing it over and over again, you can write all these in a script. You can save it, and then you can run that script as many times as you want, and it's going to do the same thing for you every time. And then if you want to edit it, maybe alter some things in it, you can go in it, edit it, change some commands out in there, and then save it, and then run it like that. So it's convenient if you're doing something repetitive and you don't want to keep typing out all the commands. It's a nice way to do that, as well as automate things. So how we would edit one of those files is a VI program, which is the visual editor program. So like in Microsoft, you have Word. So that's kind of the equivalent to Word here, which is VI, or Vim is what I prefer to use, which is just VI improved. And I'll show you those so you can kind of see the difference. And there's also a lot of other Unix text editors out there, which can be used to create a shell script and save it to the disk for subsequent execution. But unlike other programming languages such as C++, we don't have to compile shell scripts in order to execute them. But because of that, we're not going to see any syntax errors until we try to run the script. And it's not going to tell us each one. It's just going to run it from the top to bottom. And as soon as it hits one, it's going to tell us, hey, line 7, this doesn't make sense. I'm stopping because I'm broken. I don't know what to do from here. So that's the only downside to this being not compiled ahead of time, is it's not going to tell you all the errors at once. It's going to tell you each one by one. You're just going to have to go in there and fix it line by line until you get your script working. So why would we use bash? So it's nice because we can orchestrate system startup and shutdown tasks. We can automatically rename a collection of files. We can find all duplicate files and MP3s on a hard drive. We can orchestrate a suite of tools for cracking a password database. Find weasel words in your writing. Implement a relational database out of text files. And we can simplify configuration and reconfiguration of software. And this doesn't even scratch the surface of what we can actually do with bash. This is just some common examples. We can do a lot with bash. I mean, any command in Linux that you can run can be written in bash and written into a script. You just got to kind of think about the logic of the computer and how it thinks. If you can kind of get your mind wrapped around in that way, you can do a lot with bash scripting. So bash is a scripting language. And to create a bash script, we always start with this little guy here. This is called a hash point. So it's just
a hash.
Mm-hmm.
What is called hash point?
Let me type it into the chat here. So let me get back to me. document. There we go. Maybe that's all right. Let me exit out of this for me. Oops.
Some people call it shebang. I was just kind of,
And I was gonna say that's the other one it's called.
okay.
Why is it not letting me get in chat up here? Okay, I can just spell it for you. I'm not sure why it's not letting me exit out of this. But hashpling is just HASH and then PLING. And then just like you said, it's also called shebang sometimes. And all this is doing is this is just telling the interpreter which shell we're actually using when we write the script. So in this case, we're using bash. And this is the path to that shell. We can also use K shell, which is just KSH, which we would put here, or Z shell, which is ZSH. So depending on what language you want to use, you would use that on the first line here. And it goes at the top of the file. So this is the very first thing you put.
Okay.
So there are some differences between, Z shell and C shell and bash. Typically, though, bash is going to be the most versatile. So you don't have to worry too much about, if someone takes your script and uses it on a different machine. Bash is usually the most common shell used. It's the most forgiving, typically. But, just keep that in mind that if you are using different ones, you're going to have to tell the interpreter which shell you want to use when you're writing a script. Once we start that script, though, and save it and make it how we want, we actually have to make it executable so that you can use it. So to do that, we use a command called chmod or chmod. And how I typically remember that is like change modify. And then we do a space and then U for user, which in our case is going to be ourselves because we're making the script. And then we add or plus sign X for executable space, and then whatever we name that script. So we would put the script name here. So what this is doing is it's changing permissions on that file, and we're adding executable permissions for the user. If we didn't do this, when we tried to run the script, it wouldn't let us. It would tell us permission denied. And that goes for all files. In order to actually use a file or activate it, it has to have executable permissions on it for whoever's running it. It has read permissions. We can look at it all we want, but we can't do anything with it. Typically, how you run a script, gotta remember not to click on these. Typically, how you run a script is you do // and then the script name. So what this little dot and slash means is that we're looking in the current directory and we're telling it what file to run. And then we can even pass parameters to the script, which we're going to look at later. But you just do the same thing. You do / the script name, space, and then whatever parameters or arguments you want to actually feed into the script. So in the scripts, we can actually have placeholders. And when people add arguments or parameters to it, it'll fill that into the script and run it with whatever arguments or parameters you pass to it. But we don't have to worry too much about that right now. We'll go over that in a little bit. So just like I was talking about up here, when the shell does execute, the first thing it's looking at is that hashpling or shebang, and it's telling the interpreter what shell we're running. And in this case, it's going to be bash. So this is typically looked at as a comment. The only exception to that is with that first little hashpling or shebang. Otherwise, if we put a hashtag or a £, it's going to be commented out, and the script isn't going to actually interpret anything it sees after this £.
Okay.
So here we see a very simple script. So we have our hashpling here, and then we have our comment. It's just saying use $1 to get the first argument, which is echo. So when we do echo, that's the same as print, I think in C. C might be the print command. But all this does is it's spitting out whatever we put after it. It's simply just putting back on the terminal what we see after it. In this case, it's going to be the variable $1. So in Linux, when we want to designate something as a variable, we use the $sign. In this case, is a special variable, which is reserved for arguments. So like I said earlier, we can feed arguments into a script. So if I were to run this script here, let's just say I called it echo.sh, and then I put a space, and then I put hello. When I run the script, it would just echo the word hello to me because the first argument I gave it is being echoed right here. We have at the end of all this, we're going to have examples for all of these, and we have one specifically for how arguments work. For right now, the big thing to know with this is that hashtags or pound signs mean comments, and anything after those won't be interpreted as commands. And I guess $sign is how we tell it something is a variable. So here's another example. And this one, we're actually using K-shell. So we have our hash plane, our shebang. We're telling it we're using K-shell. And then we see a comment. So how the scripts run, it goes from top to bottom, left to right. So it reads this line first. Then it goes to the next line. It sees this as a comment. And it's going to know that none of this is going to be interpreted. So it sees that little pound sign, doesn't interpret anything on that line, then it goes to the next line. Then we have the clear command. So it's going to clear everything. And all clear does is anything that's on our terminal screen, it wipes it out. So it gives you a brand new screen. So if we had a bunch of text and commands on there, when we run the script, it would clear our screen out. So it sees that clear command, then it sees another pound sign, and it's going to ignore all of this. And it's going to go to the next line. It sees an echo. And then we see inside of parentheses text line 1. So when we use echo, typically we want to encapsulate things in parentheses. Otherwise, we run the risk of certain things being run as commands. So if we did this without parentheses, it might echo text. And then it might think that this word is a command, and it might mess up. Or it might work. It just kind of depends on if this is actually a command or not. But just to be safe, it's always good to put parentheses around things that we want to actually echo out. And these are typically referred to as a literal string.
So print and echo do the same thing, to just
Yep.
print. Okay.
Mm-hmm. In some languages, coding languages, they use print. I think it's maybe it's Ruby or Python. I think that uses print to do the same thing as echo. Bash, you can put both, and it's gonna do the same thing. So it goes through this line, gives us that text line 2, and then it comes to this last line. And we have an exit 0 here. So what this does is it tells us that as long as all of this worked, that it's going to go ahead and run the script. If we were to put like a exit 2 here, it would only work if that specific error code came up when we ran this. So in Bash, every time something doesn't work, even though it doesn't show us, it spits out an error code to the system. I mean, this can range from like 0 to like a ridiculous number like 492. You can Google the specific error codes. Sometimes that's helpful, but anything other than 0 means it didn't work. If it spits back 0, that means, whatever we just did worked. So in this case, we're saying, as long as this runs through correctly, to go ahead and run the script. So exit with a 0. So this can be helpful later. Like if we're writing like if then statements, we might say, if this first part works, do this. And if we get exit code, 2, then do this part. We can also run arrays and variables. So to set a variable, simply we use the equal sign. The variable can be a word, it can be a number, but I don't recommend setting a variable to a number because that can get confusing. And even though it may work sometimes, other times the system might not like it and it'll mess things up. We can use letters. I also wouldn't use, I mean, you can, but I wouldn't use characters such as like a percent sign or, a period, just because those are actually used as other things in the system. So you always want to avoid using things that are commands in the system or, special characters that the system uses. It's typically best to just use characters or words as a variable name. So here we see an example of that. Foo, F-O-O, is the variable name. And we want to set that variable equal to 3. So when we do that, it sets the variable equal to 3. And then when we say, hey, I want to see what this variable has, it's going to show us that it equals 3. Now, we don't want to put spaces in between it, because what the system's going to look at that is okay, foo is a command, space, here's the argument, and then here's an extra flag or parameter to this argument. So when we put spaces like that, the system's going to interpret each one of these differently as its own separate thing. So syntax is super important in Linux. So when we're setting variable, there's no spaces in between any of it. Now, if you do want to use a space when we're writing a script, the safe way to do that is to use some double parentheses here. This is kind of a sub-language that exists inside of Bash. And you can do a lot of things with these double parentheses that you wouldn't get away with normally in Bash. So we see here, if we encapsulate it with these double parentheses, we can do foo space equals space 3, and it's still going to set the variable foo to 3. Now, like I said earlier, if we want to tell the system that we're actually talking about a variable, we have to use the $sign. And if we want to see what's inside that variable, we use echo. So we just do echo $sign foo, which is saying to the system, hey, I want to see what the variable foo holds. Show me what's in it. And it's just going to print off the value of foo to standard out. So standard out is what we actually see on the screen. So when I type something into the terminal, that's standard in, because I'm sending something into the terminal as a command. And then it does something, and then it spits something back out to me, which is the standard out. And that's what I actually see on the screen. Have you ever actually worked with terminal in Linux or seen any of it?
Yes, I have.
Oh, okay, perfect. Yeah, so all that stuff that you see it spit out to you is all standard out.
Mm-hmm. Okay.
So sometimes we want to get rid of a variable name. We want to actually delete what's inside of that variable. So we set it by doing foo equals 42. So now the variable foo equals 42. And then we want to see what's inside of that variable. So we do echo $sign foo. So we want to see the variable foo. It's going to print out 42. So if we want to get rid of that, we actually do unset. So unset is a command. Then we do a space foo. And that will actually get rid of what the variable foo has inside of it. But it doesn't actually delete the variable. That variable is still going to exist. So if we echo foo, that's still a variable now because we've already created it. But it'll print nothing because now that variable holds nothing.
Okay.
You can also assign variables to other variables. So in this example, we have two variables. One's going to be foo, one's going to be bar. So we take the foo variable, we set it equal to $sign bar, because that's how we tell the system that something's a variable. And this will assign whatever the value inside a variable bar is to foo. Now we can actually assign values to a variable with spaces in it, but we got to be careful how we do it. So if we were to do foo equals x space y space z, again, the system's going to think, okay, I'm setting variable foo equal to x, and then I have a command y and an argument z. And it's going to get confused. It's not going to, know what to do with it. So instead, what we have to do is we have to do foo equals double quotation mark x space y space z quotation mark. And again, it's going to take this as a literal string and assign it to foo.
Okay.
Now, sometimes the system can be picky. We're going to have to wrap our variables inside of these curly braces. That kind of happens when you start getting into those double parentheses and you start encapsulating things and you want to separate your variable from other things. So it can get a little bit tricky when you use that. If you're just doing a simple, like we're doing up here, you don't need to encapsulate it like this. Before we go any further, though, I want to go ahead and show you some of these on the terminal. Let me swap out screens here. So I'm going to go to my virtual machine. See my Ubuntu machine here?
Excuse me?
Do you see my terminal here?
No, I don't. I just see your presentation.
Oh, okay. Go ahead and switch for me. There we go. How about now?
Okay, I do now.
Okay, perfect. Okay, so this is a virtual machine I'm running. This is Ubuntu. I'm not sure if you ever heard of Ubuntu,
Yes,
but it's just
I
a
have.
flavor of Linux. Okay, perfect. Excuse me. So I'm just gonna hit CD. I'm gonna hit enter. This is gonna take me back all the way to my home directory. I'm gonna hit ls to show me what files I have. And I'm just gonna go to bash class, which is a directory made just so we can kind of play around in there. So to do that, I do cd space. I want to go to this directory. So cd is just kind of change directory is how I remember it. That might even be what the command stands for. Do bash class. And now I'm inside that directory. Do ls. There's nothing in there. So we're gonna go over some of the examples here. We kind of talked about. So any of these commands I just did, cd, ls, can be done inside of a bash script.
Mhm.
So let me go back to that very first example we had, which is a pretty simple one. Yeah. Okay. So if I want to create a script, I got to edit a file and give it a name. So how we edit anything in Linux is VI, which is a pretty basic editor. I like to use Vim, which is just VI improved. So it's kind of an upgraded version of it. That's because it gives it colors and it'll actually kind of show you if things are typed incorrectly just based off of what kind of color gives it to. So we're going to do Vim and we're just going to do test.sh. Anytime you write a script, I recommend giving sh as an extension name on it. That way, if you see any files in any directory, you see .sh, you know it's a script. So it's just an easy way to kind of differentiate scripts from files. So once I hit enter here, it's going to take me into the editor. It's going to give it the file name test.sh. So I'll hit enter. So now I'm inside of the editor here. If I want to actually edit this file, if I type right now, nothing's going to happen. That's because I'm in command mode or exec mode. So to actually edit this file, I have to hit I on my keyboard, which stands for insert. And now if you see at the bottom of my screen here, I know I'm in insert mode and I can start typing anything I want. So we always start with our scripts with the pound sign or hashtag sign, exclamation point, /bin, and I always use dash. Then I'll go to my next line. I can write a comment here. I'm gonna write this is our first example script. Okay. Typically, comments are used as a way to describe things in a script. So you're not going to see, simple one-liner things like this typically. Instead, you'll see like a full sentence or maybe even a paragraph explaining what the next section of the script is doing or why it's set up in this script. So these are used as kind of a description for what's going on. Usually, sometimes it says nothing. You just have to kind of guess what the script is doing. So, and then I can do a clear command. And so you see how it kind of changed the color there, which is why I like Vim. Now I know that this is a command or that the script actually views this as something and not just a comment like we see up here. And I can do a comment, say this is the second comment in this script. Go to my next line here and do an echo. See again, it's that yellow color. And we'll just do text line 1. We even see a different color here in Vim. So now I know that this is kind of being viewed as just a literal string. If I were to get rid of this parentheses there and were to do echo again, you see how it stays the same color as this? So that's why I like Vim. Now I know if I start doing my next thing and start typing, I'm like, well, wait, hold up. Something's not right here. The colors are off. Then I can see, oh, I forgot the parentheses up here. So that's why I like Vim.
Okay.
You can use VI or Nano, and there's some, old school people out there that will still use it. But to me, Vim's just nice because of things like that. It just helps me see a little bit easier what's going on. So I save myself a little bit of time. Vim isn't usually installed defaultly on Linux. And it's something you have to install, but it's definitely worth it. So if you text line 2. And we'll do print. Print should be on here. I don't think we'll have an issue. And then we'll do exit 0. Now, this is my script. I'm good with it. I'm satisfied with it. So I want to save it. And to do that, I have to hit escape. And you'll see this insert down here disappear when I do that. So I hit escape. So that's gone now. So now I know I'm in exec mode or command mode. If I start typing anything on my keyboard, oops, might have hit I accident. But when I'm in exec mode, I can't type anything there. Except for there, I think I accidentally hit I. Yeah. So if I want to get out of this, I have to hit colon on my keyboard. We see that little colon pop up down there. W for write, and then Q for quit. I could also, if I didn't want to save this at all, like I just said, you know what, I don't want any of this, I could do a Q exclamation point, and it's going to exit out of this, so it's not going to save anything. Do a write, quit, because I want to save this file, and then I want to exit it. If I just do W, it's just going to write it and save it, but I'm still in there. And it even tells you, hey, I created this file called test.sh. It's new. There's 7 lines to it, and there's 161 characters in it that I wrote. Now I want to quit it, so I could just do Q. Everything will still be in there. If I want to view what's in that file, I have to use the cat command. Show me what's in that file, which is everything we just wrote. Okay. Now, before I can actually run the script, I have to make it executable. So to do that, I use that chmod command space. I want to do user plus executable. We can also do a plus executable, which will be all. So in Linux, there's 3 permissions you can set. You can set permissions for a user, which is typically yourself or whoever is logged in right now and who you're logged in as. You can do a group, so you can assign users to groups. So I may have 8 people and I want those 8 people to all have the same permissions, and I can assign them all to a group. Or I can do all, which is other, or all 3. Or sorry, other is its own thing. All is all 3. So other is the 3rd permission we can set. So if someone's not a user, if someone's not in a group, they're going to be other. A will do all three. It's going to give user, group, and other executable permissions. Sometimes you may not want to set it for everyone, and you do just want to set it for just the user. So we'll just do user in this case. Now I got to give it the file name that I want to set permissions for, which is going to be that test.sh. Okay. Now to view the permissions on that, if I want to see how it actually set permissions on that, I can do an ls-l. So I want to list the files. This is called a flag. So I'm telling it to do a long listing. Now it'll actually show me the permissions of the files. So this was the output of ls. Now we'll see we actually have permissions. In those other Linux courses, especially the intro one, we go a lot more in depth into how, you know, permissions work and how users and all that work. So don't worry too much about that right now. Right now, we just want to see that I have execute permissions, which I do see. So that little X there means execute. So now I can actually run the script. So to do that, I tell it, hey, look in this current directory. So / and then test.sh. And then I hit enter and it'll run scripts. Slash file text line 3. Oh, I'll have to look at that. I bet it didn't like that print work, but you see it worked mostly. So it did clear most of my screen. It echoed, you know, text line 1, text line 2. And I was a little worried that print might not be installed on my machine, which I don't think it is, which is why it erred. But just to make sure, let me check that file again. I just don't think print is installed on this machine. Yeah, I don't see any typos here or any spelling errors. I think what's going on there is I don't have print installed on this Linux machine, so it doesn't know what this command is. So no big deal there. But the rest of it worked. It cleared our screen out. It echoed text line 1 and text line 2. What's even weirder, though, is it actually looks like it recognized that command print, but it's thinking that this is like a file. So that's odd. Okay, let's go to our next example here. Setting variables. So variables are pretty important in scripts. That's kind of what gives them depth and versatility. So if we want to set a variable, in the examples we used, we were calling the variable name foo. And I want to set it equal to the number 6. Okay. So that's all I would do. So I'm setting the variable or the value 6 to the variable foo. I hit enter. It's not variable set. I want to see what's in that variable. So I do echo $. So I'm telling the system that, hey, this is about to be a variable. Foo. I hit enter. And there we go. 6.
Okay.
Now, if I want to get rid of that, I use the unset command. Now I got to actually give it the $, because we've already created this variable. It already exists now. I don't have to make it. I'm just unsetting it. I want to get rid of the value inside of that variable. That's really all a variable is it's just a placeholder for value. So we can put all sorts of things inside of variables. We can put, like we saw earlier, we can put other variables. We can put numbers. We can put literal strings. Sometimes we can even, which is a little bit more advanced, I can put a whole command and script inside of a variable. And I would just have to encapsulate it in parentheses. So it would do all, like a whole string of commands. Whatever that spits out as a value, I can assign to a variable. So the variable is just a placeholder for a value. That's all it is. So do unset foo. I hit enter. Huh. Oh, I need to get rid of this $. That's why. Okay, no $. There we go. And then now if I echo variable foo, there's nothing in it. So So it's empty. Now, if I want to put spaces in this variable, I have to use that double parentheses. And then if I echo the foo variable, you'll see it's equal to 3. If I try to do that, the spaces without the parentheses, it shouldn't work. Yeah. See, it tried to read this as a command. So it looked at this, then it saw space. So it's like, okay, foo's a command, obviously. This is the first argument to it. This is the second. So it's telling me, hey, I don't know what command foo is. And it even tried to give me other commands here, which is kind of funny. I didn't know ru was a command or goo. So instead, I would have to type it like this so that it doesn't get confused. Same with literal strings. So if I want to do foo equals x, y, z, this isn't going to work because it'll see this first part here. It says, okay, I see we're setting this as a variable. We're giving a command y an argument z. So it's going to get confused. See, so it sees this, says, okay, set x to the variable foo, run command y, and give it argument z. But it doesn't even get to z because it sees y. It says, I don't know what that is. So I'm going to stop working now. Just like the scripts on the terminal, it runs left or right. So it just keeps going until it sees something that doesn't work and it stops there and it gives you an error. So if I want to do this correctly, I got to do foo equals, and then I got to give it parentheses and say, this is a literal string. I want you to give it the exact thing inside of this parentheses, literally as I'm typing it. Now, it doesn't get angry. It doesn't spit anything at us. And typically in Linux, if it says nothing, then that's good. So we'll do echo $, because we're telling it it's a variable. Give us the value of the variable foo. We have x, y, z. I do echo $, I use those curly braces. Should give us the same value, which it does. We're not going to worry too much right now about what special cases we'll use for that. It's a little bit more of an advanced topic. All right, let's go ahead. Oh, here's our chat window finally. You go to what I was going to type there earlier, so hash plane. All right, let me go back to my PowerPoint screen. There we go. Okay, so there are some variables that are reserved in Bash. So we want to avoid using those reserved variables. Otherwise, it's going to get confused. So some of those reserved variables are special Bash variables. Are actually shown right here. So we have $0, 1, 2, 9, 10. Then we have 10 inside of curly braces, and then we have the pound symbol. So 0 prints the script name. Excuse me. 1 is going to print the first argument, 2 the second argument, and we just skipped a bunch of numbers here. So 3 would do 3, 4, 4, all the way up to 9. 9 would print the 9th argument. 10, written as it is here, is actually going to print the first argument followed by a 0. So if we want to actually print the 10th argument, we have to do it this way. We have to give the curly braces, and then it'll actually give us the 10th argument given to a script. And then 11, 12, so on inside with curly braces. The $, pound symbol is going to print the number of arguments we've given to the script. So if I do a // then a script name, and then I do space like 1, space 2, space 3, and run it, If we have this inside of that script, it's going to tell us that we ran it with 3 arguments. So these are all special bash variables that we can use inside of a script. It's also possible to write arithmetic expressions in bash, but we have to be careful when we're doing it. So we can do it this way. We can use the command expression, expr. And how that would be set up is we do the command expr expression space 3 plus 12. That's going to give us 15. However, when we do expr space 3 times 12, this is probably going to crash because this is a wildcard in Linux. This is called a splat. So the splat wildcard. And this is used in a special way in Linux. If I were to use this on a file or a name, typically, depending where I use it, it's going to mean all files that like end in this word, or all files that begin in this word or end in this letter, etc. So if we run it like this on the command line, it's going to get confused. It's going to think, okay, I'm looking for all files that have start with 3 and end with 12. It's going to get confused, and it's probably going to crash. So if we want to use it, this splat symbol in this way, we still use the command expr, and we do 3, and we actually use a backslash. So in bash, this means ignore. It's going to say, hey, there's nothing special about this character. Use it as is, times 12. So we'll actually use it as a multiplication there. I don't really know anyone that uses expression. Typically, everyone's going to use the parentheses, how we're going to see here in a minute. But it's good to know that this exists because it is still used sometimes, and you want to be able to understand what's going on there. So the easier and safer way to do it is this double parentheses, which is kind of what we saw earlier. You use double parentheses a lot when you're bash scripting, just because it's more forgiving. It's also a little bit more versatile. So we see here we're doing the same things as before, but we're able to use, a little bit more normal symbols and setup. So if we use double parentheses, we can just do x equals 3 plus 12, and then echo variable x. So we're actually assigning a variable because equals, just going to assign a variable. So x equals 3 plus 12. And then when we do echo variable x, it's going to print out 15 because 3 plus 12 is 15. Same here, we can use multiplication without having to ignore it as a special character. So we say variable x and set that equal to 3 times 12, which is going to give us 36 if we were to echo variable x.
Okay.
We can also do the same thing without having to assign it to a variable. So if we just want to run these and we want to spit out the value immediately without having to echo a variable, so we don't do, assignable equals expression, we can set it up this way. We can echo $3 plus 12. So we do $, double parentheses, space 3 plus 12, space double parentheses, and it'll print out 15. So what we're doing down here is the same as up here. It's just in this case, we're not actually assigning it to a variable. We're just immediately running it and echo out what it does. I'll switch over to my VirtualBox here. Show you that. Yeah. I'm actually going to do a clear screen just so we get a little bit of space here. All right. So we're going to look at those reserved bash variables. So I'm going to write a simple script here. To do that, I gotta do vim. We're gonna call this argument.sh. So now it's gonna open a file named argument.sh. Now to edit the file, I gotta hit I for insert. And I always start my scripts with the hash plain or shebang. Tell the interpreter what shell we're going to be using when we write the script. So I'm going to go ahead and use a couple of those special variables. The first one was echo $0, which will give the script name. And I'm going to do echo $1, which is going to print the first argument. And I'm going to do 3. I'm going to skip 2. Say echo $3. So this will print the third argument. And I'm going to do one more, which is going to be echo $, and pound. Now, usually, remember this pound sign is a comment. But remember, the script or the interpreter runs left to right. So it's going to see this $sign first, and it's going to know, okay, this is a variable. It's that pound sign. Okay, if I were to flip-flop this and put the pound sign first, it would ignore that $sign. So if I did it like that, it's going to go left to right. It's going to echo and then comment $sign. This would actually be interesting to run like this. I bet it might echo this as it is. Or might echo nothing. I'm not sure what it would actually do. Keep it how we're supposed to do it. Okay, so we have our script here. It's a simple one. So echo the name of the script, echo the first argument, the third argument, and then how many arguments we gave it. So if I want to save my script, I got to hit escape on my keyboard, colon, which we see down here, W for write, Q for quit. So I'm writing it and quitting it, I'm exiting out of it. Now, before I run it, I have to make it executable. So chmod space, I'm going to do user. I'm going to add executable permissions for the user to the script I just did, which is argument.sh. I'm going to hit enter. I can double check that. So you can do a ls-l. There's also a shorthand version of this, which I like to use, which is just LL, long listing. This is the exact same as if I were to do ls-l. You see, even with this, we actually got a little bit extra on it. We got these two weird files here. So those are called hidden files. Anytime you see a period in front of a file, it means it's a hidden file. So if I do an ls, it shows me these two files here. If I do an ls-l, which is a long listing, I get the permissions. If I do an ls-al, that's a long listing as well as hidden files. So A shows hidden files, which is what we saw up here when I did LL. So LL is a shorthand version of this right here. But anyways, that's kind of off topic. So I just wanted to confirm that when I ran this chmod command that it did give me executable permissions, which it did. So I'm going to go ahead and run that script /argument.sh. So what this should do is it should give me the script name, the first argument, the third argument, and then number of arguments. So if I want to give it arguments, I got to do space. The first argument I'm going to give it is food. The second argument I'm going to give it is bar. And the third argument I'm going to give it is just, I don't know, pa. Okay. So what we should see happen is it's actually going to give me this argument. It's going to skip this one because I didn't tell it to echo the second argument. It should give it this third one. So let's see what happens. Perfect. Okay. So it gave us the script name. It gave us the first argument. the third, and then another argument. So let's go ahead and look at that file. So like I said, it runs the script top to bottom, left to right. So the first command we had in there was script name. So it gave us the script name. The second command we had in there was tell us what the first argument is, which it did, foo. Then the third command it had in there was tell us what the third argument is, which it did, pa. I didn't tell it to give us the second argument, so it skipped that. So there's the third argument there. And then finally, the last line in there was tell me how many arguments that I fed into that script, which it did. I fed 3 total. So even though it skipped this telling me what the second one is, it told me I gave it 3 total because that's what I told the script to do. So sometimes this is helpful to add arguments into a script because it makes them a little bit more interactive.
Okay.
All right, so let's kind of go over the expressions a little bit. So actually, let me clear my screen. So if we do expr, that's a command in Linux expression. I tell it add 3 plus 12. And I hit enter. It gives me, oh, need to cancel it here. Oh, okay, it's just printing out. Interesting. I wonder if I don't have that installed on here. Script. So let's just do add.sh. Try it this way. Now I'm going fast here. I just want to check something out. Might not have that package installed on my command line, so it might not like it. Still doing interesting. Okay. I think, like I said, expression is kind of I don't see anyone use that anymore. It's kind of an older one. And Ubuntu is kind of a newer version of Linux flavor. So I think what's going on here is I don't actually have all the packages installed that I need to, and that's why it's just spitting it out to me as a literal string. So I'm not gonna be able to show that one on my Ubuntu machine here. But what it should do is it should take this as an expression, and it should give me back 15. I'm gonna show you that wildcard character splat here. So I have 3 scripts here that end in .sh. So if I do like an ls, I do that splat character .sh. This is saying, hey, list back everything that ends in .sh, which it does. Actually, an even better example of that. I don't have that as a machine, do I? If I go to CD, it's not a good one either. A bunch of files in here. Okay, cool. This will be a good example. So we see several files in here. Some of them end in this .yaml. So like maybe I just want to see these files inside this directory. So if I do like an ls splat and tell it, hey, anything that ends in .yaml, tell me, which it does. So we know there's more files in this directory than just the .yaml. But because I use this special wildcard character and I told it, hey, show me everything that ends in .yaml, that's what it showed me. Okay. So the point of showing you that was in that PowerPoint, like we said, if I were to do, just expr 3 splat 12, it would probably get confused. Yeah, like I said, I don't have the correct packages installed for this expression command worked. But normally it would get confused and see this as a special character like it did up here. wildcard, and it wouldn't work correctly. That's why we would have to use the ignore or backslash. It would normally ignore that as a splatted character. But I'm going to show you how most people would do an expression. So if we do parentheses, double parentheses, x equals 3 plus 12. There, okay. Now I echo the variable x, which we assigned here, 15. Which is what we did here. So we had variable x. We added 3 plus 12, which of course equals 15, and then assign that to x. And then we echoed variable x, and we got 15. We can also do that with multiplication. So x equals 3 times 12. You don't have to worry about it seeing this as the splat character because we're inside of these parentheses. Now we can do echo $x 36. Okay. And this is a good example of how the command line is no different than writing a shell script. I mean, this is technically coding the way Linux is set up. You know, I'm using it on the command line here, but it's super inconvenient to have to type this out, then echo it, then type it out. I'd rather just open one file, write all this at one time, and save it, and then run it. Because, I mean, what we're in right now, this is a bash shell. All right, let me go ahead and clear my screen. We're going to go back to our PowerPoint. We're going to get into the actual good stuff, which is constructs for bash scripting. All right, so we're back in our PowerPoint here. Before I go any further, those are anything you have questions about or anything you're unsure about?
No, I'm following along.
Okay. And if you feel overwhelmed at any point after this, that's probably a normal reaction. I mean, even I still learn stuff all the time about bash scripts that I didn't know about, or you know, just people who have been doing it longer than me show me. So totally normal to feel overwhelmed at any point if any of this stuff seems like a lot. Okay. So like I said, we're going to look at some constructs inside of bash scripting. So usually inside a bash script, we use the following programming constructs. We can use a conditional statement like if else. We can do loops. We can do functions, or we can do any combination of above. Okay. We are going to look at some of these very briefly in the advanced bash scripting course and the bash scripting course intro one. We go over these a lot more in depth. I mean, we'll spend entire lessons on just this one, just loops, just functions. So today we're just going to kind of briefly go over them. The first one we're going to look at, which is the most common, is the if, then, else construct. Okay, you'll actually see this in a lot of other scripting languages as well. However, in bash, this condition is actually command, and the exit status of 0 is true, while an exit status of fail, which is anything but 0, is false. Okay, and that's important to know. And I'm going to explain why here in a second. That's because when we do if this first statement is true, then do this. So that's why knowing that the statement only works if it proves true. So if this first statement were to prove false, it's not going to do this other part after it because it didn't come out as a true statement. It only happens if this part is true, then we do this. And then we end it with fee, which is just if spelled backwards. And this is kind of how we set it up. So we do if, our statement, then do this, which is usually a block of code. And then when we want to finish the statement, we do fee. So something wouldn't work if this proves false. It's going to skip all this and it's just going to end the statement. It's not going to do anything because this came out to be false. So this would not print. So Bash could take different actions on whether a program succeeded or failed. So if the process HTTPD starts, then echo HTTPD started. It's okay. Else echo it failed. HTTPD failed to start. So if this part is true, if HTTPD started, then we echo this. Else, so if this wasn't true, it was false, do this. Echo HTTPD failed to start fee. And we end our statement. And this can go on and on and on and on. I can do if this was true, then do this. Else, if it was false, do this. Else, if that was false, do this. And I could keep going on and on with these statements. So it doesn't have to just be two statements. We can set up a lot of conditions within this if statement until eventually one of them proves true. It does that, or false, and then it ends the statement. We also have the while command. So the while command will do commands until the test completes with a non-zero exit status. So while something is true, keep doing this over and over and over and over again until it's false. Then it's going to stop. And we finish that with done. So this is how we finish a while statement. We start with while. We give it an expression. And if that expression is true, do our block of code. And then we finish it with done. Whereas before, on these if statements, we start with if. Give it a statement. If that statement's true, then we do then. Give it our code block. Else, code block, and then we end it with fee. This one is while, do, we end it with done. So let me switch to my virtual box and do a very simple version of that. Come up with one here. So we'll do vim if.sh. Okay. So now I'm going to write up a script. I named it if.sh. I go into insert mode. Always start with my hash string. Say we're going to do an if statement. So if, and how you typically write your statement is you want to encapsulate it inside of parentheses. You don't always have to, but that's the safest way to do it. So I'm going to do a single parentheses. I'm going to say if, let's do this. I'm going to actually assign a variable here. I'm going to say x equals 1. Okay. So in our scripts, we can always assign a variable. And then for the rest of the script, anytime I call this variable, it'll know what it is. If I try to call a variable and I don't assign it in the script, it's not going to know what the variable is. So I have to assign it somewhere. And typically you do that at the top. So I'm going to do my if statement if, I'll do parentheses, x equals 1, close parentheses. I do a semicolon, then, and now this is also another reason I like vim. I'm going to hit enter, and it actually indents it for me. So it sets up how it's supposed to be set up. So when we do our if statements, we always have our if. We have our statement here. And if this proves true, then do this. But in order for the second part to run, we have to indent it. So we have to nest it inside of this if statement, which is what we did here. So now I'm going to say echo x is 1. Okay. Now I could do it then. So let's say I do then. And again, vim set this up for me. I didn't have to indent it all. That's why I like vim. So it knows that then has to be in line with this if here. And then I'm going to run my next code block. So it indented it for me again, because now it's in line with my other code block. Echo x is not 1. Now I want to end my statement. This is all I want my if statement to be. So to end it, I do fi, and Vim's going to set that up for me correctly. So I have to line that up with if. So if x is equal to 1, then echo x is 1. If x isn't equal to 1, then echo x is not 1. I'm going to save this. So I'm going to do escape, right quit, W2. I need to make it executable. So user plus executable, do if.sh because that's the script name. And now I'm going to run that. So ./if.sh. Looks like I have a syntax error. What did I do incorrectly here? If then something like the if then so get rid of that. There we go. Okay. So what the error there was, let me go back to that. I had two thens. So how I originally had written it is like this, which is incorrect. I was getting my methods mixed up in my head. So I don't need this then because I wrote it here. And so it was just kind of yelling at me like, I don't know why there's two thens. So that's what was going on there. But anyways, we'll run it. F.sh. So it tells me x is 1, x is not 1. It gave me both. Interesting. Oops. Okay, let's take it like this then. There we go. Okay. All right. Okay, so I'm probably getting a little bit ahead in our PowerPoints here, but so how I'm setting this one up. So if x equals 1, semicolon, then then echo x is 1. Else, if this isn't true, echo x is not 1. Okay. So in this case, when we ran it, oops. In this case, x does equal 1, so it spit out that first part to us. So this proved to be true. X does equal 1 because the variable x equals 1. So it just did this first part for us. If I were to change that script up a little bit, I say, hey, if x equals 2 instead, well, we know this isn't going to be true because x is equal to 1. So this first part's going to prove to be true. So if this is true, then do this part. If it's not true, do this part. So we're going to save that. We're going to run it again. I'll show you what's in the script. So now we have a 2 there. So I'm going to run the script again. So I'm going to do ./if.sh. X equals 2, then x is 1. here. It's interesting. Oh, it's not too bad. All right, we'll have to finagle with that a little bit, but main thing to know here is this is how our syntax works. So we have our if statement. We have our statement here. Let me simplify this, get rid of this thing. So we have our statement here. As long as this proves true, it'll do this first part here. So, if this is true, do this first code block. Then if it isn't true, then do this part here. And then we exit it with phi. So we end our statement there. Actually, I wonder if I was trying to overcomplicate it. I wonder if it was running like this. No, it's gonna give me both done. Yeah. Okay. So we can also do the while statements. So let me create a script called while sh. These are kind of set up similar in how we do the spacing. So I would do my while command. And then I would do some statement here. So while do x equals 1 again. So while x equals 1, and then again, Vim's going to know that this needs to be indented here, so it indents it for me. So while x equals 1, do echo. That needs to be indented. It doesn't always indent it for you though, so it knew that do needs to be in line with this. But when I hit enter and typed in echo, it didn't indent it for me, and this actually does need to be indented. So I had to do that manually. So echo x equals 1. And then I always end a while statement with done. So we're setting up these spacing while my statement x equals 1, do. So I put it in line with while, just like with if, I had to make the then and the else in line with it. So do has to be in line with the while. Then I space it out. This is my code block. So echo x equals 1. And then when I end my statement, I do done, and that needs to be in line with my do and my while. So I can do a right quit on this. And I need to make that executable. Wow, that's h. Okay, so what we're seeing happening here, while statements will continually go until that statement proves to be false. X equals 1, so this is going to go for infinity. That's never going to change, right? Because we gave it a variable x equals 1. And that's always going to be true. That's never going to change until I go in there and change that statement. So I actually can't get out of this unless I send an interrupt signal, which is going to be Control-C. And then it'll finally stop running that script. That's kind of important to know too. You can actually do some harm to yourself if you create a loop on accident in your scripts, which we saw there. So it may actually run a script infinitely if something like that happens. So if I go back to that script, make sure it doesn't. So in theory, if I change this to 2, it shouldn't run. So I changed this to x equals 2. This statement should prove false, so it shouldn't do this. It should just exit out of the script, or it should tell me that, hey, that doesn't work. So let's go ahead and try running it. Now it keeps running. Interesting. Okay. Well, I'm writing something wrong in the syntax there. I'm probably trying to overcomplicate it, or maybe I'm undersimplifying it. But the main things we're looking at here is just how it's written syntax wise, just the spacing and the indentations here. So we always start with a while script. With while, we give it the statement. The do is going to be in line with the while. We do a space. And then we give it the code block, what we actually want it to do if it's true. And then we always finish it with done. Let's go back to our PowerPoint here. The next one we're going to look at is some examples. So on these examples here, we're actually going from the very beginning of all the stuff we learned, and then we're going to go through all the other things that we just talked about. So some of these scripts are going to start pretty simple, and then we'll actually get into the for and if and all that. So the first one we're looking at here is a really simple script. I'm sure we can guess what this is going to do. This is just going to echo hello world, but we'll go ahead and do it here. Do you have some type of virtual machine setup?
Yes.
You do? Perfect. Yeah, that'll help a lot with the Red Hat exam. Any of the stuff they're talking about, I would just pause the video and try and do it on your virtual machine. The catch with that is sometimes they're going to assume that you have things installed that you might not. Like even now on my machine, like that expression command, it was kind of working, but I think I'm missing some packages, which is why it won't run it as it's supposed to. So that's kind of the downfall of not having the lab environment set up the way they need it when you're doing some of those Red Hat courses. But if you do end up paying for the subscription, they have all that set up, all the files that are supposed to be there are there, you know, all the resources, all the users. So they have everything set up. You don't have to worry about that. But we're gonna do this first script here. It's a simple one. We're just gonna call it vim hello world. We're just gonna call it hello.sh. So I always start with my hash string. And we're going to start with a comment. So this is a comment. And we're just going to echo. Hello. And even on that same line, we're going to add a comment. Just say this is still. So it's going to run this. The interpreter is going to see this first shebang. It's going to say, okay, I'm using the bash shell. Then it's going to go to this next line. It's going to say, all right, I see this pound sign. So I know this is common. I can ignore this. Let's go to this next line. It's going to see, okay, echo command. I'm going to echo hello world. Okay, I see another pound sign. So I'm going to ignore this part. So we'll go ahead and right quit. Okay. And then to run it, what do I need to do now? Do you know? What's my next step here?
To run it, you have to do a chmod u plus x.
That's right. Yep. I need to make it executable before I can run it.
Right. And then
I named it hello.
Hello. That's sh.
Yep. Perfect.
And then do a ll. Right.
You don't have to do this. This is just for my own sanity.
Okay.
I want to like double check that it is executable now. You can run it without checking.
And then do ./ and the name of this what's hello.sh.
Yep, that's right. And this is actually a /.
Okay. I'm sorry, /.
Oh, you're good. In Windows, everything is /, I believe.
Yeah.
Which is that little character there. In Linux, though, everything's /.
Right.
I shouldn't say everything, just about everything. Yep, and then I'll run that, and that's what it does. It echoes hello world to our standard out here. So let me clear my screen. We'll look at our next example here on PowerPoint. Just going to be a little bit more of a complicated one. This one's going to look at the arguments that we talked about. So we have our hash string, our shebang. We have a comment. We have some echo commands here. Okay, so we're going to see how those arguments set up. Now, what's interesting in here, which can get a little bit tricky later on, is that we do have parentheses here. We have a variable inside of those parentheses. We're going to see what it does, but we know this is a variable. But we're also putting parentheses around it. So it should take this as a literal string. So we're going to see what happens when we do this script. Switch to here. Okay, we're going to name this one. Let's see what script names I got here. Oh, I'm in the wrong directory. I'm going to remove some things real quick. I'm just going to clean these up real quick. So this would actually be a good little trick to show you. In Linux, when I want to like remove a file, I do the rm command. And then earlier I was talking about that special wildcard, which was the splat. So with the rm command, I can supply multiple file names if I wanted. I could do hello.sh, if.sh, and while.sh, and it would delete all those. But I am lazy, so I'm going to do this a little bit easier way. So I'm going to use that wildcard character. I'm going to say remove everything that ends in .sh. And we see in this directory, there's only 3 files that end in that. So when I do that, I do lsn, boom, those are all gone now. So that's just one of many ways you can use this wildcard character. As long as you can kind of think about how the machine's going to interpret what you're trying to do, you know, there's a lot you can do with Linux. But that is kind of off topic. So now we're in the right one. So I had an argument.sh. I'm going to remove that file because we want to make a new one. Actually, I'll just use it. I'll just delete what's in it. Yeah, do that script. I'm going to delete all of this. A couple ways you can delete things inside of a text file. I can go to insert mode and I can just backspace or delete. Or while I'm in this exec or command mode, which we can see down here, there's no insert mode, so I know I'm in a command mode. So if I start trying to type on my keyboard, nothing's happening. The other way I can delete things in a file like this is I can hit DD on my keyboard. So I just press the D letter on my keyboard twice. If I hit DD real quick, it deletes that line. Okay. Sometimes that's faster than just like going into insert mode and backspacing everything. So we're going to go off that example 2 here in our PowerPoint. So I always start with the hash plane. And we'll put another comment here. I'm just going to say example arguments. I'll put my first command here, which is going to be echo. Let's say my name is $1. We're going to do another command. We're going to echo my name is $2. The third one here, echo total arguments is $, £.
I'm kind of following along with you, so don't exit out yet.
Okay, yeah, no problem. And that's good. I'm glad you are. That'll help a lot. What flavor of Linux are you using? Using Ubuntu?
CentOS.
CentOS. Okay, I like CentOS.
Yeah, CentOS 7.
I would recommend using that too because that's going to be the closest to Red Hat.
Yeah.
Ubuntu's a little different, like some of the commands are different. So yeah, it's good you're using CentOS or CentOS or however you want to say it. This is another reason I like Vim. It's kind of spoiling it for us, but it's even in a different color on these variables here. So
I don't think I have Vim installed. I got VI.
VI, okay. I'm trying to think on the test if Vim is even installed. I'm not sure it is, and I think it might let you, but I'm not positive. But I can show you how to install Vim. It's super, super easy.
Yeah, if I can install it, it'd be great. I think you have to do that either repos or yum, right?
On, yeah, CentOS, yep. On mine, it's different. So that's why CentOS is probably better to use if you're going to study for the Red Hat exam. Mine's actually a completely different command and repo system.
Okay, I got pretty much everything you have there.
Perfect. So to save our file, we're going to hit escape,
Okay.
colon, WQ, which is right quit. Yep. And we'll hit enter. That file is saved.
Oh, just a minute. I got something at one more file to edit present.
So you should see this at the bottom if you're in
Yeah, I do, but I'm getting a error.
when you're trying to save it.
Yeah.
Interesting. And you're using VI.
Oh, it's saved now. Go ahead.
Is it? Okay, perfect. So before we can run that script, just like you said before, we're gonna have to make it executable. So we do chmod. We do u plus x. We want to add executable permissions. And then we give it the script name, which is argument.sh.
Let's see what I call it. Call it name. Okay.
Now to run that script, you have to do dot / which is going to be right next to your shift button. It's like the question mark. And then we do argument or whatever you named it, .sh. So we got to give it the script name. Now, before we hit enter though.
I want to stop there from because said name, kind of access name as .sh. So I probably call it something else.
So the easiest way to probably check that is to probably do an ls wherever you're at right now. And it's going to list all the files you have there. And from there, you might be able to see what file it was.
All I have is probably name it sh because
okay. Is there only one file in there?
There's directory 1 start to sh and file 1. And,
it's probably sh. So when you did vi, did you like type in any word after vi?
Yeah, I did. Oh, it's called VI. Yeah, it's called SH. So
whatever word you type after VI, that's going to be the file name. It's going to assume that that's what you want the file name to be.
Yeah. We do a U plus X.
Yep.
And then we'll call it SH plus SH. SH.
All right. Did it let you add executable to it?
Yeah, I did. Someone do okay. And then do a //
and then don't hit enter yet, but we're going to type in the name of the script. And I think you're saying yours is just called sh. And what we're going to do is we're going to actually feed some arguments into the script. So let me real quick, just so we can kind of see what's actually going on here. Okay, so we're going to feed some arguments into the script, and this is the script here that we just wrote up.
Yeah.
So if I want to add arguments into the script, I have to do a space after the script name here. What I'm going to do is, in this case, it's a, I wrote it wrong. That surname here. But what this script is doing is basically it's just going to spell out your name. I was supposed to put surname here, so I was supposed to put last name, but that's okay. So we're going to put my first name is Kevin, and in your case, you put Lionel. And then I'm gonna put my last name here, Downs. Okay, and that's all I'm gonna put as far as arguments here. So what we should see is it should say my name is Kevin, and then again it's gonna say my name is Downs. It's supposed to be surname, that's all right. And then it should tell me that there's 2 arguments. We're gonna go ahead and enter and see what happens. That's exactly what happened.
Like that. My name is Line. Oh, my name is Line Green. Yeah, mine ran. Total number of arguments is 2.
2, yep. And even if we ran that again and we just put, random words after here, food, bar, like, smell, and we run it again, it's still only going to take the first argument here. And it's still only going to take the second argument and fill it in here. But it's going to tell us we have 6 arguments total now, because that's what this is looking for. That's what this variable means, is it's taking how many arguments we gave it. Okay. Now, the other interesting thing to see here is that when we put a variable inside of quotation marks, it'll actually take that as a variable, as opposed to taking this as a literal string. However, I go back into that script, and inside of this, I do echo. Oops. Need to hit insert mode first. If I put echo, which me and you both know now is a command, we're going to see what happens when I try to run that script. So we're going to do the same thing we just did. I'm running that script. I'm giving it a bunch of arguments here. It ran that as a literal string, right? So let me do this. Okay. So this is the new script that I just added in there. I added echo inside of this first string. I gave it a bunch of arguments, but it didn't run echo as a command, right? So if you ever try to put commands inside of parentheses like this, or I'm sorry, quotation marks. I don't know if I've been saying parentheses the whole time, but I meant quotation marks. It's not going to take it as a command. It sees this as a literal string still. However, variables get seen as variables still. That's important to know inside of these quotation marks. If I wanted to make this a command, I could. There's a way we can do that. I'm not going to get into it on this webinar just because that goes into some more of the advanced topics of bash scripting. But there is a way for this to actually be seen as a command still inside of these quotation marks. That's the main takeaway here, is that it still saw this as a variable inside of the script. And this also shows us how we can add arguments into a script when we run it. Right? Because these didn't exist inside of that script. We added them into it, fed it into the script, and it placed those arguments inside of these variables. Okay. Let's go back to our PowerPoint, check out the next example here. Okay. Oh, okay. So do we just do this? We did. So this is just showing you, if you were to type in the arguments into that script, Hans, Lloyd, it would come out as that. So that's what we just did. So let's skip this part. We're going to look at our third example here. So we're looking at how to do those expressions again using double parentheses. So our hash playing, oops, go back. Hash playing, and then we're going to add 2 numeric values. We're going to put that into a variable, and then we're going to say, hey, show me that variable, and we're going to run it. So let's go back to our virtual machines here. Do clear. There's also a quick way to do clear. If you don't want to type in clear, you want to be lazy. I think it'll work on CentOS. You can do a Control L and also clear your screen.
It does work in CentOS.
Does it? Yeah, okay. So I'm as lazy as I possibly can be. So any shorthand versions of stuff that I can do, I like to do. But if you want to type in clear, that's fine. It's good to know the original stuff. Okay, so we're making another script here. Let me make sure. Cool, I don't have it. So I'm gonna make a script to do that. Oh, let me show you how to install Vim on your machine. So it's not gonna work on mine because this is Ubuntu, but on yours you would do a yum install Vim, and that's all you would do. I'm gonna hit enter, and it's gonna tell me I don't know what yum is. On Ubuntu, you have to do apt-get install.
Yeah, mine is saying that can I find a valid base URL for repo base? So let me
Yeah, you might not have all your repos set up.
yeah,
Let me think of what Vim is in. I think that's probably gonna be
let me
it's probably gonna be your EPEL repo.
let me use a different hold on for a minute. Let me use a different machine that I have like 3 or 4 machines set up.
Oh, do you? Okay.
Yeah.
I'm thinking it's probably you'll probably just need to get your EPEL repo set up.
Yeah.
Which is also pretty no big deal.
Let me see. It's coming up. Okay, let's move forward. Just do okay, I'm back.
Okay. Are you on a different machine?
Yeah, different machine, but I still can't install Vim, but I'll do that later. Let's move forward. I can at least I can
Okay.
do VI, so that's good.
Yeah, that's fine. That'll work too. It's pretty similar. You just don't get the fancy colors and all that.
Yeah.
So we're going to do Vim or VI in your case. And then remember, whatever word I type here is going to be the name of our script. I'm going to name this one, let's just say number.sh. I like to put .sh at the end of it so I know it's a script when I'm looking at all the files I have. And that's, I mean, everyone's going to do that. So I would get used to naming your scripts in this way. So this is really the name here of it, number, and this is an extension .sh. And this will tell anyone that looks at your files that this is a script here. And they'll just know that by seeing that extension on it. So I hit enter. I'm in my text editor. I'm going to hit insert or I. I'm going to add my shebang at the beginning. /bin/batch. We're going to add a comment here. We should say add to numeric values. And then after that comment, we're going to do our double parentheses. We're assigning a variable here. So sum equals 25 plus 35, double parentheses. Earlier, I think you showed me use, or I think I showed using spaces here. I can do that. It's not gonna really matter because the double parentheses is pretty forgiving.
Okay.
Enter and go to my next line. I can add a space here, or I can just do my next comment. It doesn't matter. The interpreter doesn't care. If I just add a blank white space in there, all it's going to do is it's going to come to this line. It's going to see there's nothing. It's just going to go to the next line. So I can add a space just to make it look nice. A little bit easier to read, human friendly. I'm going to say print the results. So in order to see what this equals, I have to call what's inside of this variable. I have to see what's in it. So I'm going to do echo $, because that's how Linux knows something's a variable. And in this case, the variable name was sum. So that's what we put here. Echo the variable sum. Okay. That's all that's going to be in this script. So we want to do an escape, colon, write, quit. I'm going to hit enter. So now we have that script written, but before I can run it, I got to make it executable. And then in my case, this script was named number.sh. And just for my sanity, I'm going to do a LL just to check that that is executable.
Yeah.
And it is. So I know I can run it. Now, if I want to run it, I got to do a / number.sh. I hit enter. 60.
At the same time. Fantastic.
Yep. So that's a pretty simple way to do expressions inside of a script. And all this, I'm sure, seems very simple right now. Maybe you don't see the use in some of these things. But when you start adding all these things together and using them in conjunction with each other, it can be pretty useful. And we can set up a, you know, if people are doing their taxes and stuff like that, I mean, we could set up a script that'll run certain taxes. And we say, you know, run the script, and then we can even have prompts that say, what was your gross income? And then they tell us the gross income, and we can feed that into the script as an argument, which will be assigned a variable inside of a, you know, a equation like we're doing now. So, you know, you see you're using kind of 4 different concepts there, and you're kind of joining them all together. And then we have a script, you know, that can like give you your, you know, tax bracket based off of what you insert as your gross income. So,
Okay.
you know, you can combine all these concepts we're learning right now into one script, and it can actually become pretty useful.
Yeah.
But, you know, if it's new to you, it can also be very difficult at first, just until you get used to the syntax and, you know, remember all the different commands and whatnot. Let's go back to PowerPoint. And again, I didn't take the version 7 test, so I'm not positive, but I don't think you're gonna have to worry about any bash scripting at all on the test. So I wouldn't worry about it too much. All right.
Version 8 has it?
No, version 8 for sure didn't have it. I took version 8 of the test, and I can say with complete confidence that it was not on there. Not in the way we're learning it, anyways. Like how we're doing here, like you're not gonna have to write a script on version 8 of the RHCSA.
Version 8 has something that version 7 didn't have. I think it was, I can't remember the name of it, but
Yeah, so yeah, version 7 and 8, that just means the version of RHEL or Red Hat that they're using. It's really like the same test. It's just version 8 is using RHEL 8 and version 7 is using RHEL 7. I think the only big differences between like 7 and 8 is RHEL 7 uses ifconfig instead of like a different way to set networking interfaces. And there's like a couple other commands that are different. It's been a while since I've taken the test, but there's just like very small differences between the commands between RHEL 7 and RHEL 8. And RHEL 8 also hits on a new file system, which is Stratus and VDO. So those were new concepts introduced on the RHEL 8 test. And you either get one or the other. You either do video or you either do Stratus, and you won't do both. And I don't think those were on the Rel 7 test. So very small differences. I don't think either one, though, has you write a bash script. Definitely not on 8, but I don't think 7 either. I forgot what screen I'm on here. There we go. Okay. All right, so this is actually getting into that interactive thing I was just talking about. So we're seeing a new command here, which is read. So what read's going to do is we say, hey, enter your username. This is just a simple echo command. And read is going to take a variable, and whatever user input we get, it's going to assign it in the variable here. So read is the command. This is the variable name. And it's taking whatever input we get from the user and putting it inside of this variable. Okay. So we're going to do echo, enter username. We'll see that on the terminal as the standard out. It's going to wait for us to input something. It's going to take that input and put it in username. It's going to go to the next line here. It's going to say enter password. It's going to wait for us to input something. And then it's going to take that and assign it into this value. And now we see a huge line here, which is a little bit more than what we're used to. This is kind of what I was doing earlier with that x equal. And like I said, I think I was just like overcomplicating it. And that's why it wasn't working. So we have an if then statement. So if this proves to be true, then echo valid user. Else, if this isn't true, echo invalid user. Okay, we see a lot of square brackets and parentheses and quotation marks, equal signs, and all this here. I'm going to explain all this. So we'll kind of start with pieces in here, and then we'll work our way out. So we know this is a variable here, okay, by the $sign, and we also know what this variable is because it's up here, right? We assign a variable up here, and we put some user input into it. So that's what's going to get put into here. This double equal sign means equals to. So username equals to, and then we have a string here, right? Because we have some quotation marks. It's a literal string. So the word admin is what this is. Okay. So if username is equal to the word admin, and then we have two ampersand symbols here, and this is and, but this also goes a little beyond just and. This also means if you see a double ampersand symbol, this part has to be true and this part has to be true. If this is true and this isn't, this whole statement is going to be false. That's what this double ampersand symbol means.
Okay.
Okay. And this whole thing will prove to be false, and it's going to skip this part of the code block. It's going to go straight to this, right? Because this whole thing proved false since one of these wasn't true. That's what this double ampersand means. Both have to be true for this whole statement to be true.
Okay.
We see another $sign here. So we know this is a variable, and we know what this variable is because we assigned it up here. We created it up here. And we just talked about this double equal sign. It means this has to equal this. We see quotation marks. So we know this is a literal string. This is the word secret. That's what this is. So password has to equal secret. Okay. Now we want all of this to be interpreted as one thing. So that's why we use the parentheses here. If we don't use the parentheses or the brackets here, it might get confused. It might try to say like, if username equals admin and password, and then it might like try to interpret this as something separate. It just might trip up Bash a little bit. So it's good to encapsulate this so that it knows it's one thing. And it doesn't try to like individually look at each piece of this and try to figure out, okay, is this part of this or is this part of this? So we throw some bracket or parentheses around to make it one thing, okay? And then when we do if statements, we throw the double brackets around it so that it interprets all this as it's supposed to be. This is supposed to be variable $sign, quotation marks, this double ampersand symbol. These double equal signs and double ampersand symbols might not work unless we have these double brackets around it. Okay, so we're looking to see if this entire statement is true, semicolon, then do this, which is echo valid user. Else, if it isn't true, else echo this fee, and we end the statement. So we're going to do this on our virtual machine, and we'll even break it to show you what happens when it's not true. So we'll put in some false info. All right, so clear my screen. So we're gonna do vim. Let's call this one, let's just call it read sh, or you can name it whatever you want. Hit enter. So now I'm in my text editor. It even shows me down here what my file name is right when I open it. So it's read.sh. I hit I for insert mode. And we always start with shebang. Okay. Now the first thing we're doing here, let me even add a little bit of space. I like to add spaces in between the shebang when I type in. I'm gonna do an echo enter username. I'm gonna close that out with a quotation mark. Then I'm gonna hit enter. And I'm gonna do the command read space. And now whatever word I put here, that's what the variable will be. In this case, we're gonna call the variable name username. So now this is a variable. Okay. Then I'm going to do another echo statement. Enter password. I'm going to hit enter. I'm going to do another read command. And now I'm going to set up another variable. I'm going to call this variable password. I'm going to hit space. So now I have some echo statements set up. I have some variables set up. They don't have values yet though, because it's going to take user input and put it into those. And now I'm going to set up this kind of larger if then statement. So if space, I'm going to do double square brackets, which is kind of above your entry key. And I'm going to do a parentheses. And I'm going to say the user or variable username, double equal sign equals quotation mark admin. And again, I can put spaces here if I want to, which would be fine because we have it inside of that parentheses. It shouldn't matter. We'll see. It might yell at me, but I don't think it's going to. I'm going to close that out. So now I have the literal string admin, the word admin. I am going to put a space here. I'm going to put double ampersand sign. And I'm putting a space here just so it's easier to read. Now I know that, this one part is a statement, and then I want this other part to be a separate statement. But then if you didn't put spaces there, it shouldn't matter. The interpreter would be fine. But just for the sake of my human eyes, it's a little bit easier to read this way. I'm going to put a second variable, which is password. Okay. Is it important to use these variable names because that's what we set up here? If I put, different words down here as variables, it's going to have no idea what I'm talking about because, I haven't assigned these variables anywhere in the script. So it wouldn't know what these variables were. So that's why we got to use the same names. Let's say double equal sign equals the literal string secret. And now I need to close it out. So I opened this parentheses. Now I need to close it out. And I also opened a double bracket. So now I need to close that out. I close that out. Okay. Now I do a semicolon. Then. And I'm going to hit enter. On VI, I don't think it would indent it for you. So you'll have to indent it here. And then we're going to put echo, quotation mark, valid user. And then I'm going to hit enter here. And we need to make sure that our else is in line with our if. And then I'm gonna hit enter. It did indent it for me, just not like the same as that. But I'm sure as soon as I hit echo here, it'll probably, no, it didn't. That's interesting. Just for the sake of things looking nice, I'm gonna line this up with my other echo. I don't have to though, as long as this has at least one space or one indentation, it would work. It knows that, you know, this is the code block. Okay, but it's just nice to make everything look similar and neat. Just makes it easier to read. We're gonna do invalid user. So that's our next code block. I'm gonna end this statement with a fi. So to read what this actually means, if username is equal to the string admin and password is equal to secret, then echo valid user, else echo invalid user. Okay. So if we put in admin and then we put in secret for password, then it's going to echo valid user. If we put anything else but admin and secret, it's going to break the script. We're gonna check that out here. We're gonna see if that actually happens. So we're gonna save and quit out of our script. I'm gonna do a chmod because I need to make it executable. My script name was read.sh. So I'm gonna hit enter. So now that's an executable script that I can run. Do ./read.sh because that was the name of the script. And now we're gonna execute.
You want to stop there for a minute? I'm trying to catch up.
Sure. Yeah, no problem. And let me know if you're running any snags or anything.
Run it. Okay, I'm with you now.
Okay.
The username, okay.
Yep. So now you see it's actually asking us for something. We have a prompt here and it's kind of interactive and it's telling us, you know, supply a username, you know, type something in. We're going to put admin. We're going to hit enter. And now it's asking us, okay, enter password. So we're going to put, it's supposed to be secret. So we're going to type in secret, then we're going to hit enter.
It says
and boom.
valid user, yeah.
Boom, valid user. So that's pretty cool. Let me show you what happened there. So it asked us for enter username, right? That's what this echo statement did. Okay, it just echoed this. Now, the reason it opened up that prompt for us to actually type something in is because of this read command. So that's what the read command does. It kind of opens up this interactive prompt and it allows the user to type something in. And then whatever they type in, it puts into this username variable. Okay. Then it went to the next line here and it ran the echo command. It spit out enter password to the standard out or the terminal, which we saw. And then this read command opened up and wanted us to type something in. We typed in secret, so it fed the word secret into the variable password. The reason it echoed valid user is because username did in fact equal admin, right? That's what we typed in. And it also did, or the variable password also equaled secret. So this part was true. And this part was true, which made the whole statement true. So it echoed this part, okay? We're gonna run that script again. Another shortcut, if you hit up on your D-pad or your little arrow keys, it'll actually show you all the previous commands you've run. So if you don't want to retype something in, you can just hit up and it'll go back to any previous commands you did. So we're going to run this script again. This time, I'm going to type in Kevin for the ad or for the username. You can type in Lionel or whatever name you want. I'm going to hit enter. Now the password, I am still going to type in secret. Then I'm going to hit enter. Oh.
Yeah, mine said valid user.
Yeah, that's interesting. I wonder if, again, this might just be, so there's different ways to type equal. Let me see if I get rid of that double equal sign. That's kind of an older way of doing it. Let me get rid of. Got some spaces in there. Oh yeah, that's why. I bet that's why. Maybe not. Let me check. Oops. Okay, yeah, there you go. All right. So I was actually wrong a little bit. This is why I like Vim. So I didn't add spaces there like I should have. So it's interesting that it likes that one, but it doesn't like this other one. Okay, so you need spaces in between this double equal sign.
Okay.
So I guess to be safe, just add spaces in between everything that are unique, so like this variable, add a space, and then do the double equal sign. This literal string, add spaces before and after. Okay, that seemed to have fixed it. And that's another thing with this scripting stuff. Sometimes you just got to keep tinkering with it until you figure out why it works. And sometimes it's okay to know, or for it to work and not know why. As long as it's just working, that's all you really care about. But in this case, it was because those spaces weren't there. So we're gonna run that script again. So I put Kevin.
Well, let me see. Let me see how you did yours again. Your script.
Yeah,
so I can...
sure. Let me exit out of this. Okay. So the mistake we had there is originally I did not have spaces here.
Okay.
Which I think is probably how yours is set up.
Yeah.
So what we needed to do to fix that is we needed to add spaces before and after those equal signs.
Gotcha.
And that seemed to have fixed it.
Then you just did a slash. What did we name it again? What was the name of the script?
I named mine read.sh is what I named it.
Yeah.
So when we run that again, I'm going to use Kevin as the username. I'm going to go ahead and do secret as the password, which is correct, which is what we're supposed to use.
Invalid user worked this time.
Yep, perfect. Yeah, so I'm going to show you what happened there. So, oops, oh, rad. No, that's not what it is. Read. Okay. So what happened there is we did username as Kevin. I'm sure you put Lionel. And obviously that does not equal admin. So this part of the statement was false. However, password was secret, which made this part of the statement true. But like I said, this double ampersand sign means that both of these have to be true for the entire thing to prove true. And if we remember at the very beginning of the PowerPoint, we said in these if statements, this has to be true for this part to run. And that's kind of different in Bash. Other languages don't necessarily operate like that, but in Bash, this has to prove true in order for this to run. Okay. I'm going to clear my screen real quick. Do you also know about the tab function? How to like complete stuff?
Yeah.
Okay, perfect. Yeah, that's super handy too. Okay, just to get that up so we see what's going on. I'm gonna run this again. What was it? Read.sh. I'm gonna put Kevin as my username, and I'm gonna put Downs, just my last name is the password, and we see it still tells us invalid user. Okay, so this is just to show too that even if I make both of them false, the whole statement is still false. I mean, obviously, as long as one of these are false, the ampersand is going to make the whole thing false. But I just want to show you that the script does actually work as intended if I make both of them false. So this is cool. I really like that feature. Read is a pretty
Yeah.
cool function because it makes it kind of an interactive thing. So let me head back to my PowerPoint. I think we're going to get into functions here. Or maybe we're going to do the wow. Yeah, we're going to do functions here. How you feeling? You need a little brain break or need some food?
Yeah, please. Let's just take a break and come back.
Sure. So it's like 11:20 right now. Let's
Mhm.
say like, you gonna grab some food?
Yeah,
Okay, let's say like 11:50. Let's meet back here. You think that's enough time?
that's enough time.
Okay, cool. Yeah, 11:50. We'll meet back here. Do me a favor though. Don't exit out of Zoom since there's only two of us.
Yeah,
If you exit out, it's just me. It's gonna close the session. So go ahead and stay
right.
logged on. Hit mute or whatever you want, but just stay logged on. Okay.
Okay, what are you going to name this this script here so I can?
The one we're about to do.
Yeah,
I'll probably name it. Are you actually on my PowerPoint right now? Can you see this?
yes, I can see a
Okay,
PowerPoint.
cool. I'll probably name it fact.
Okay, that way I can write it in once before we start, and when we can get started.
Sure.
Okay, great, thank you.
Yeah, no problem. We just meet back at 11:50. Alrighty, let's jump back into it here. So we're going to start on something that's called functions. I've seen an example of one of those here. So the command function is reserved in back. So when we use the command function, it knows that we're about to set up a function, and the word that comes after it is the name of that function. So we see here we have a function, and it's called fact. So when we write out a function, we use the command function, space, the name that we want to use for it, and we use a curly brace. And then everything inside of that is body. So all this is the body of that function. And then we close it out with a curly brace on a new line. And in order for this to actually run, we have to call on that function by giving it the name, which was fact in this case. So here we have a variable. We're setting it equal to 1. Then we have another variable. And we're setting it equal to a variable 1. Okay. So we're using a while statement, if you remember that. We used a, so we learned about if statements. We also used or learned about while statements. So we have a while statement here. So we're saying while variable in, and then this means greater or equal to. So dash GE means greater than or equal to 1. So while variable n is greater than or equal to 1, do, we're setting the variable result equal to expression, and then we're using the variable n here. And remember, this is just to escape that special meaning splat.
Mm-hmm.
So while variable n is greater than or equal to 1, do, we're going to set variable result equal to variable n times result. So a lot going on there. And then we're going to set n equal to the variable n minus 1. And then we're going to go ahead and finish that while statement. And then we're just going to echo what the new value of result is. Okay, so there's a lot going on here. So I'm going to head to my virtual machine. Okay, let me clear my screen here. And I would worry less about what's actually going on in this function and what all this means. And I would worry more about the syntax of it and how we're setting it up. So I'm going to do vim. I'm going to name this fact.sh because we're still writing a shell script. Okay. And I'm going to hit I for insert mode so I can start editing this here. So I'm going to use my hash button always. I always start with the hash button. Okay. And then we go ahead and start this function. So I'm going to use the command function. I'm going to give it the name fact. I'm going to open it up here. So now I'm going to hit enter. So I'm in the body of my function. You see it went ahead and indented it for me. And the first thing we do is I'm going to do result equals 1. So I'm setting a variable equal to 1. So I'm setting variable result equal to 1. And then I'm setting another one. So a variable named in, I'm going to set that equal to $1. Okay. And if we remember, $1 is actually a reserved variable. So that means the first argument. So whatever argument I feed into this script, it's going to put in here. Okay. Now, set up my while statement. So while, use brackets. So square bracket, $in is greater than or equal to 1. Close that out. Do, say, we're going to set the variable result equal to $. Now remember when we were also talking about we didn't want to, we wanted to do expressions, but we didn't want to have to assign a variable to get the result out of it. We just want to get it immediately. We can use that $sign and then put it inside of a parentheses. So that's what we're doing here. So expression. And this should work. I think inside of a function like this expression command should work okay, but we'll see. Backslash to escape this special character meaning. We want it to mean multiply. Result. Okay. So we are saying basically, go ahead and multiply in by result, which in this case is 1. And whatever this new value comes out to, then assign it to result. Okay. We're going to do none n equals $, parentheses, expression. We're doing the same thing here. We're going to we want to give us the answer to that equation and then immediately give it back to us. And we're going to assign it to n. So expression, $n. This 1. We're going to close that out with parentheses. We're going to finish this while statement. So I want to complete it, and to finish a while statement, we do done. And then after it runs all that, I want it to go ahead and echo the variable result. Okay. And now I want to close my function out. I want to go ahead and finish this function. So to do that, I'll hit enter and I'll hit curly brace. You see there, Vim did it for me, but you want that last curly brace to line up with function. So now this closes my body of my function by typing that there. Okay. So now my function's closed. I have my variables set up inside of my function. I have a while statement set up inside of my function. And then I also have an echo statement inside of that function. To run the script as is, it would do nothing because I'm not calling the function. I'm not telling the script to run it. So now I have to tell it, I want you to run this function. So to do that, I have to call the function. And the name of the function is fact. So now, when I run the script, it's going to see this function. It's going to see everything inside of it that it's supposed to do. And then it'll get to this line and it'll run it. It'll actually do everything inside of here, okay? So we have two variables here, result and n. We set result to equal 1. We set n to equal the argument I give it. So when I supply an argument in there, for example, 1, it would throw 1 in here. So then n would equal 1. It would also equal 1 here. So 1 greater than or equal to 1, which it is. So since that is, while it's still that, it's going to do this. It's going to do result equals 1, because that would be the argument I give it, times 1, which is going to equal 1. So now result still equals 1. And then n is going to equal 1 minus 1, which can be 0. So now n equals 0. Done. And then echo result. Okay, which is still going to be 1. So let's go ahead and do a right quit. Let's see how that works. Oops, right quit. I'm going to cat that function just so you can kind of see it, and then I'll explain what it's doing as I type this in. Okay. I need to make that executable, user plus executable. And then I need to give the script name. There we go. All right, so I'm gonna go ahead and run that script. Fact.sh. And I'm gonna supply it the argument 1. Let's run it. No. In syntax error, line 4. All right, let's see what it doesn't like here. Line 4. 1, 2, 3, 4. Result equals 1. Oh, what's wrong with that? Oh, he doesn't like that. Oh, 1 sec.
Name means function, and it's, when I try to run it, says no name. There's no bash file by the name of function. Do I have to change it to fact?
Are you trying to run the script?
Yeah.
So whatever you typed in for VI after that, whatever you named it, that's what the name of it's gonna be.
It's not. It says okay. Let me.
I'm trying to figure out why it's angry about this variable here. It's weird. I actually ran this last night and it worked fine. Okay. Maybe a space here, maybe. What's it saying? 1.6 missing. Missing a square bracket. It's not true. My square brackets are here. Yeah, I wondered if it went like that. Double parentheses should. Is that? All right, sorry about this. 1 sec. Doing a little troubleshooting. I don't know why it doesn't like this. I ran this last night. It worked fine, but it's not that good enough for some reason now. Okay, whatever. There we go. Okay. So I had to. The first mistake that I made was I forgot to put a space here. So that's the first thing it yelled at me about. Is you have to put a space in between the name of the function and that first curly brace. So that was the first error. The second I wasn't liking is that it didn't recognize this -GE greater than or equal to. There's another way you can write this, which is Yeah, greater than or equal to. But it just depends on which version of Bash you're using. So what I did is I used double brackets, and I think I'd have to look at the different versions of Bash. But different square brackets and parentheses, like you can use different ways to write things. So like I said, there's two ways you can write greater than or equal to. This way, oops, there we go, that way, which would be greater than or equal to, or -GE. And if we're going to do it this way, we have to use double square brackets. So that's what fixed the script. So that's actually what it should look like here. So when I run it now it does actually.
Oh, hold up! Don't get it out, because I am putting everything that you have there. And
scroll down so it's easier to read. I'm gonna add something here, just because the way the script's written is kind of goofy. It's always going to be one. So let me do an echo. Oops. And yeah, and there as well.
after the curly brackets below, do you have to have the do you have to have the, for instance, I name mine's function. After the curly brackets, do it have to be function or fact like yours?
So function is the command. That's how it tells
Right.
Bash here that we're writing a function.
But I
Fact
name
here,
mine's function.
oh no, I wouldn't name it function. That it's
Okay.
going to look at that function again and probably get
Oh,
confused. It may name it function. I'm not sure if it would work, but I would not do that because that's probably a bad practice to get into.
yeah.
You can name it fact, or really you can give it any name you want.
Oh.
We also named our script fact, which is fine. Or that's what I named mine. But this is just the function name here, fact.
Yeah.
You can type any word in here, and that's just what the name of the function is going to be.
That's why mine isn't running right, because I name it function.
Oh, okay, yeah. See, I figured it would probably get confused if you did that.
I gotta get out and come back in again.
let me know when you got all that, and then if you're running
Yeah.
into any snags, let me know, and I'll try and talk you through it.
Okay, come out of there now. We can save it.
Okay. Escape right quick. Okay. Let me clear my screen. And I'm going to just cat that file, just so we can see what's in it. I can kind of explain what's going on when we do it. Okay. So I'm going to execute that script now. I'm going to feed it in the argument of 1. So when I run the script, I'm giving it the argument of 1. So we talked about earlier in the PowerPoints that $1 is a reserved variable, which means the first argument, which should be 1 in this case. So 1 will get assigned here. So we'll say while 1 is equal to or greater than equal to 1, do 1 times, and in this case it's going to be 1 since result equals 1. And of course that's going to equal 1, so it's going to feed back 1 into the variable result, so it'll still equal 1. And then we're going to do 1 minus 1, which will equal 0. So n will equal 0. Okay. And that's going to finish this while statement. Then we're going to echo the new value of result, which we get from here. And it should give us the new value of n. Okay. I added this part in. This isn't on our PowerPoint. I'm just kind of curious what it's going to say the variable is going to be. I just want to see. Then we close the function and we call it. That way it actually runs when we run the script. So let's see what happens. Blank. Interesting. Okay. So I gave it the argument of 1. It's echoed. So it ran through all of this and then echoed the new value of result as well as the value of n. 1 minus 1 is 0. Which is interesting. It should have gave us 0. I'm not sure why it's giving us a blank number. Or not even numbers, just giving us a blank value. That's interesting. Let's go ahead and run it again. And instead of 1, we're going to do like 5. Let's see what happens. Still 1. Interesting. So let's see.
Issues at mine too. It says had issue with the word done. I don't know.
What, didn't like the word done?
No.
Okay. Make sure that done is in line with while here and do.
Okay.
Yes, we want to make sure that that is in line with while and do. We want to make sure this part is.
I don't have the word do. Okay.
Oh, miss do? Yeah. Mm-hmm.
Yeah.
Yep. So do always comes after the while statement.
Right.
So while this part is true, do this.
Save that.
It still doesn't like the do, or I mean, done.
No, I'm coming out now. Let me screen.
Okay.
I got 1 and a 1 as a result. Did you make some changes?
The only thing I added was this part here.
Yeah, let me see. I think I had that.
Yeah, that wasn't in our PowerPoint. I was just curious what it would tell us n is going to equal after this.
Already had that at my. Okay, yeah, pretty much everything what you got there now.
Okay, and is yours running correctly?
Yes, it is, but what it's saying is when I input 1,
Mhm.
I get a 1 in return, 1 in return twice.
Oh, so your N is actually working. Wonder why mine isn't. That's what I expected it to give me. So yours is echoing the variable result and the variable N.
Yeah,
And
no,
mine is
isn't.
as well. I'm getting 1 for result, which makes sense. I mean, anytime you multiply, 1 by anything is going to be 1. And then same here. This should equal 1. So yours is actually working better than mine. I don't know why mine's just giving me a blank value. So yours is working properly.
Oh, okay.
Yeah. And it really doesn't matter what number we put here because, like I said, 1 times result, which is 1, or anything times 1 is always going to be 1. So really, no matter what number or argument we give here, it's going to come out as 1. I could change the value of result here to be like 2. And then it's going to really change things up because now we're multiplying whatever argument we give it by 2. But we'll keep it simple here. That's why we just did 1. But that is how you write a function. We're going to look at another way to write functions here, which is honestly the way I think most people will probably do it. All right, so our next slide here. Oh, okay. We're gonna actually go through, before we look at a different way to write how functions are written, we're gonna do how to write those expressions with the double parentheses, which is much easier with double parentheses as opposed to writing the actual expression. So essentially we have a pretty similar thing going on here, but now it's just not cluttered with all of these, expression command, backslash, and all that. It's just much easier to write it with double parentheses here. Okay. So we go to my virtual machine. Same thing's going on. It's the same function, but now we're using see. So I'm just going to delete all this. Actually, I just deleted it all. We're right from scratch. Okay. You can, since we're doing it all from scratch, you can just remove that whole file if you want, and then do a VI and name it. I think the last one was fact, so we can name you can name it fact again if you want, or factor. Doesn't matter, whatever you want to name
Factor.
it. Okay, that'll work. And then when you got yours open, let me know.
Okay, ready?
Okay, perfect. So we always start with bang here, and to write our function. So I'm gonna hit space and just like gotta get in insert mode. And just like adding a line in between the shebang. So function, whatever word we put here is going to be the name of the function. And you went with the name factor, I think. So you named your file factor. I'm going to go ahead and name the function factor as well. And now we need to open the body of this function. So we have to do the curly brace. And then we're going to hit enter. And then I think you'll have to indent yours. I don't think VI will do it for you, but it may. So we'll have to indent on this next line. And then we're going to set up a variable named result. We're going to make it equal to 1. And then we'll hit enter and indent again. Then we're going to do another variable. We're going to make it n. And we're going to set that equal to $1, which is a reserved variable, which is the first argument. And then we're going to hit enter. and we're going to indent. We're going to do another while statement. I guess I shouldn't say statement. This is really a loop, because this will keep going as long as the statement proves true. So we'll do while. We're going to do double parentheses, and this way we don't have to use the expression command. We're going to do in. And this is where we can use the other way to write greater than or equal to. So we use the greater than sign and equal sign. 1 parentheses. And make sure we got spaces in between all of these. Saying while in is greater than or equal to 1. Oh, you know what? Oops, I need to put a $sign here. Or actually, no, we don't. With double parentheses, we don't have to put the $sign. Since we're assigning. I'm going to put it just for the sake of keeping things consistent. So we'll put $sign just so we know it's a variable. That might mess it up, but I don't think so. I think we should be okay. So while in, variable in, is greater than or equal to 1, do, and do should be in line with while. And we'll hit enter, and this we will indent. So while n is greater than or equal to 1, do variable result. These adding this $sign here might mess it up inside these double parentheses. I'm going to run it and see. I don't think it will, but it may. And if it does, we'll just come back and delete these $signs. So do variable result and times results. So this is similar, like I said, to our last one. It's the exact same. We're just writing with these double parentheses now. Last time what we did is we did what we did is we did result equals, and then we did expression $sign. Don't type this part. I'm just showing you what we did last time. Boom. Result, I think is what we did. So last time, this is how we wrote it. This is a variable, so I gotta put $sign in. That's how we wrote it last time. This means the same thing as this. But since we're using these double parentheses, we can write it like this. You don't have to escape the special character. Anything like that. Okay. So let me go ahead and delete this. And like I said, these $signs might come back to bite us in the butt, but I'm going to try it just for the sake of keeping things consistent. Okay, and then we go to the next line, double parentheses, variable in is equal to in minus 1. So we're taking our first argument, which is n, variable n, and we're going to subtract that by 1. And then we're going to assign that back into the variable n. So now it has a new value. That's all we want this function to do. So I'm going to do done. That's all we want this while statement to do. So I'm going to hit done because I want this while statement to finish. That's all I wanted to do. It's in line with my while and do here. Then I'm going to hit enter. And we're going to do echo the variable result and echo the variable n. Now we want to finish the function. So I have to hit enter. And then I close out the body of it with that curly brace here. But in order for this to actually function all the way, if I were to run the script as is, this function would not actually run and give us the results because I have to tell it to run. So I have to call the function. We name the function factor. So all I have to do is type in factor here. And now we're calling on that function to run. So then it'll actually run all of this. And then when you got all of that, let me know and we'll save and quit out of this, or write and quit.
So n minus.
And we're going to see if this will actually work correctly.
Is that an equal sign, the second parenthesis, and $ n?
This guy?
No, the other one down.
This guy?
Yeah, also equal sign, okay.
Mm-hmm. Yeah, $n equals $n minus 1. Is this screen small? I can try and make it bigger if I need to.
It's just certain things equal is kind of small, but it's good. It's okay. Result equal, and then you have result equal $ and times.
Over here, see if this makes a difference. Any bigger here?
That's good. That's good. That's good. I just have to.
Okay.
That's, result is equal to $ and $ times results. Result. And in the while, it's while $n greater than equal to or greater than n?
Yeah,
Yeah,
greater than or
okay.
equal to here.
Okay, great.
Yeah.
All right, let's close out and see what happens. Let's save.
If you made a new file, you'll have to make it executable.
Yeah.
Mine is called fact. Yours is called factor, I think. Okay. So I'm gonna go ahead and run that.
Something is, let me see, something. It's
Let me,
WQ, right? And mine is not.
WQ, colon WQ.
WQ. And factor SH, press enter or type command. This is something. Okay. Escape. Factor dash SH. think I know what I did wrong. Quit. Yeah. I made a mistake. Set up .sh, factor.sh. I had /sh, so it won't save. So I gotta.
Oh, okay, yeah, yeah. Linux is very
So,
picky about yeah, spelling and yeah, it has to be exact.
yeah, so I have to rewrite this again. Sorry about the delay.
Do you need me to open up my function again?
No, it's right there. I can see it.
Okay.
Okay, let me save this. Look at this time. Okay, I'm ready to run it. Let's run it.
Okay, perfect. So we're gonna run it. We're gonna give the argument 1. Like I said, these question marks.
I have to do a
the,
chmod and all that to make it.
yeah, if you made a new file, you're gonna have to make it executable.
Executable. Just
And once you got that executable, we're gonna run it.
Mine is
with,
saying no such, oh, God, I always do that. Don't put the suffix, sh. Okay, factual line, it says line 7, something about something greater than 1, syntax error, operand expected error token,
let me
something
see.
greater than 1. So
Okay.
I have something.
Okay. Yeah, it's getting me the same error. It might not like that $sign.
Oh, you have the same thing too.
Yeah. Like I said, those $signs might bite us in the butt. So I'm just gonna get rid of those. Oops. That's not what I called it. Okay. So what I'm gonna do, I'm just gonna go ahead and get rid of these $signs on all these variables. I don't think it likes that. So we're gonna get rid of that one.
I'll make the change, and if it worked, then I change minutes afterwards.
Okay, that's fine. Yeah. We'll keep that the same. Those need $signs. So I think that'll probably fix that, honestly. So let's run it again. Yeah, okay. So let me open that up so you can see them. So I got rid of the $signs and all these variables here inside of the double brackets. I thought it might bite us in the butt, and it did. So that's okay. So inside of these double parentheses, you don't need the $sign. It knows that this is a variable and that as well, this. And I guess it actually confuses it if you tell it it's a variable. And then when you got that changed and saved, let me know.
Okay, I'm ready to save.
Okay, so we'll go ahead and save that. And then let me clear my screen real quick. Okay, so now we have our new script. We took out the $signs. We're running it with the argument 1. We'll hit enter. Yours will probably say 1 again. I don't know why mine's giving me a blank value for n.
So having error of something greater than 1.
Still giving me an error here.
Yeah, with while $n greater than equal to 1. It doesn't like that.
Do you have a $sign on the n?
Oh yeah, I do.
Yep, go ahead and take that off.
Yeah.
Yeah, inside those parentheses, it like assumes that you're assigning a result to a variable in the beginning. It just kind of assumes that this is a variable. So I guess by adding the $sign, it gets confused.
Mine came back with a result of 1. Okay.
Okay.
Like yours.
Did it? Okay, perfect. Yeah, so it ran through that time. So the big thing we were looking at here is just that you can write it like this with the parentheses as opposed to writing it. Let me go back to my PowerPoint here. It'd be easier to show that way. So yeah, the takeaway here is that we can write it using the expression command like this, which can be pretty convoluted, you know, and there's a lot going on there. We have to add a lot of extra symbols, or we can use the double parentheses, which is a little bit easier. a little bit cleaner, and it'll do the same thing. So let's move on to our next example here. So in this one, we're going to look at a different way to declare a variable, a different way to write the function, and then we also still have the while command. Okay. So here, before we were writing function and then the name of the function, this is another way, and this is usually how most people will write it, of writing a function. So this is the function name. And then we use this double parentheses here. So we open and close it. And that's a function. So that's how it knows that we're writing a function. This is how you'll usually see it. Not to say you won't see it the other way sometimes. You'll see it this way sometimes. And you can write it this way, and that's fine. It'll still work. But this is just, a little bit quicker to write it this way. A little bit easier. You still open it with that curly brace. In here we have declare. So declaring it like this is the same as this. So we're declaring the variable result.
So you have a backtick there, right next to declare.
This is actually just a dash.
I'm right. What's above? It seems like there's a after the E.
No, there shouldn't be nothing there.
Yeah, right. Yeah, you're right on top of it. What's that? What's that?
Oh, there's nothing on my screen.
Oh, really?
That's interesting.
Yeah, I'm seeing it on mine. It looks like a backtick, but okay.
Okay. Do you see like a backtick?
Yeah, it's still a backtick there. I don't know.
That's really weird. I don't think this will make a difference, but let me hold on, let me get out of this. I'm gonna switch screens here and see if that makes any difference. That's odd. Sure. I'm not sure.
Oh, it's not showing there, but it's not there now.
Okay, yeah, that's really odd. I don't know why it's doing that. Let me okay, I'll keep that on the screen, and then let me move my.
No, so at least we know what it is. It's nothing. So
That over here. All right, let's just switch screens. Cool. Yeah, it would be confusing because a backtick is actually a thing.
Yeah.
So that would be confusing. So declare is just kind of the longhand version of this.
Okay.
I have honestly never seen anyone do it this way. But that is a way you can do it. And if you do ever see it, that's what's going on, is you're declaring a variable, in this case result, in this case in. Okay. And then this is also another way we can write function. And here we're using the double parentheses convention. We're saying while n is greater than or equal to 1, do result equals n times result, and this needs to be in parentheses. And then we're saying n equals n minus 1, done, echo result. Okay, so we're gonna head to our virtual machine, which is on this screen now.
I put different results for n, like 5, and the result was still 5. Or 1, I meant.
Oh, it came out as 1 still?
The last.
You put that in for n or result?
I put in, for instance, I had that back factor.sh, and I put 5, 4, 1 came back. I put 0, 1 came back. I put 1, 1 came back. So no matter what I put in, the result was 1.
Oh, really? Interesting. Okay. Let me look at what the logic is on here. So if you're saying, yeah, you put those in as arguments, so that's going to go into n. So yeah, 5 is greater than equal, which it is, to n times. So that should be, yeah, whatever number you should put in there is what you should get back.
Yeah.
Wonder. Okay, let me try something real quick. What do we need? I think I named it fact. Yeah. Yeah, let me try. Let's get rid of that star since we're using double parentheses. We should be able to use the actual multiply symbol. No, actually that won't work. It should be splat. Let's do space. Oops.
Maybe it'll work then because mine was kind of joined together.
Yeah, see if that makes a difference. No. Result equals. I don't want that because we're assigning it to result. While it is wonder if we need to maybe we should do it this way. Let's do dollar sign. Do it like this. Maybe that'll work out better. See if it likes that better. Let's do one. Must be something in the logic here then. Okay. Result equals 1, so this will be. I wonder if that's why it's screwing it up. This because 1 equals. That's equal 1. The new throw 1 here times whatever argument we give it. I should feed that into this as a new value. That should give that new value there. Oh, you know what? I bet I know what's going on. Let me undo these changes. So I'm gonna do a quit exclamation point, and this is gonna quit out of it without saving any of the changes I just made because I'm not like I don't want to have to retype all that. So now if I go back in it, it'll be oh shit.
Okay.
I must have saved it before I did this. Okay, never mind. That didn't work because I saved it before I actually made these changes or after making these changes. I think I know what's going on here. Let me pull up my PowerPoint so I can get it back to how we had it. Where's it at? There it is. Okay. So with this all. I know what's going on here. It's the same. Result equals n times result n equals. See that. So, because I'm just going to echo that after that. Because that's not one anymore, I wonder. No. So something's just going on with the logic here of it. Well, that's still one, so I should still run this because one is greater than or equal to one. And five is definitely greater than or equal to one, so I should run this. Okay. Well, I think the syntax on it is right. Let me pull PowerPoint or I think the syntax on this is right, meaning the spaces and the indentations and all that. I just think the logic of it is incorrect somehow. Meaning, like how this is multiplying and all that is somehow not working out correctly to give us the right number. So I would have to rearrange this so that it feeds back into the variables correctly, and I would have to mess with it a little bit.
You can move on then if you want.
Yeah, yeah. But yeah, the main part of this is the syntax of it. So the spacing, the indentation, how while works, things like that. So yeah, we'll move on, and I'll have to go back to that and see why the logic isn't working out correctly. Yeah, so we're looking at that one. Okay. So we're gonna work with writing up the function in a new way like this, as well as the variables in a new way like this. So we're gonna make a new one. We're just gonna call this, I don't think, you called the last one you had factored, right?
Yeah.
Okay, so I think I'll call this, let's just say, I'll just call it function.sh. You can name whatever you want. Always gonna start with that shebang. Add a space. And now we can write our function in the new way, which is giving it the name, space, double parentheses, and then we open up the body of the function. So I have my function name here, space, double parentheses, so now we know, or Bash knows that it's a function. And then I'm opening up the body of the function. I enter, and we indent. And then we're going to do the longhand version of declaring a variable. So declare -I result. And we'll do declare in. And then we're going to do n equals $1, which is the argument. The logic probably will be off on this one as well, since I set it up like the other ones, but the syntax should be correct. Wow. So we're going to do another while statement where we use our double parentheses so that we can do n is greater than or equal to 1. Parentheses. Do results equals n times result. Slap some parentheses on that. I wonder if I take the parentheses out, if it would still work on that. Some parentheses on this. And then we'll finish that while statement. We'll do echo. We're just going to do just result this time. We're not going to worry about it. And then we'll close our function. So it's probably going to spit back 1 to us again. Do it. We have to call our function here, which is factored. And then let me know when you got all that. And -I, by the way, means like integer. So it's treating this variable as an integer.
Okay.
Oh, while you're typing that, move grab and I'm gonna go run and grab some water real quick.
Okay.
All right, I'm back.
So, okay, got it.
Oh, okay, perfect. So I go ahead and save this guy. And we'll need to make it executable. And then when we made it executable, we're going to go ahead and run it. And we'll just give it 5 as an argument.
I came up with a result of 1.
1, okay. So that tells us the syntax is right. It's just like I said, the logic is off somehow.
Yeah.
I'll have to mess with it for a little bit. I don't know why it's not.
Yeah, I did 5 and came back with a 1 as well.
Get rid of that argument too. It's just 1. Yeah, I don't know. The logic is off there somehow. What I think it's doing is I think it's literally just. Let me go back. I think it's literally just fitting back this variable here, result, no matter what we put in as the argument. So I mean, somehow, somewhere in here, the logic isn't working and it's not giving the new value to the variable. But I'd have to play with it and figure out why it's doing that. I'm not sure, because it shouldn't be. Should be putting the new value of result back into result. But I'm not sure. That's actually the last of the examples. There are other bash scripting concepts such as arrays. There's operations on variables. We actually kind of talked about the wildcards like splat and we didn't talk about the @ symbol, but those can operate differently in bash than on the command line. There's strings, we talked about that. So strings are the things inside of those parentheses. So those are literal strings. So those are just words, whatever text we want. There's scope, which let me go back a little bit. I'll talk about scope real quick. So scope is kind of how variables are called upon. So inside of this function, we're declaring some variables, okay? Those are set locally in this function though. If I were to set up another function, actually, let me switch my virtual machine, might be easier to explain that way. So if I go back to my function here, so if I test whatever, oops, and I just say a equals 1, that's it. I'm just gonna close that out. Okay. So if I'm in this function here and I try to call on this variable a inside of this function, it's not going to work because I'm setting the variable locally inside of this function. And that's out of the scope of what this function knows. I can't call a variable in another function. I would have to set this variable globally. And how I could do that is I would set it at the very top here. So now, in theory, any function I use down here or any if statement or anything I use should be able to call upon this variable because I set it globally. It's at the top and it's at the furthest to the left indentation. So anything that comes under it should know what this variable is now. Does that kind of make sense?
Yes.
Okay, good. So that's what scope is essentially. There's also files and redirection, which you might know a little bit about. When we use the greater than sign or less than sign, we can kind of redirect output. Same with pipes. We can feed the output of one thing into a new command. and then processes. That's a pretty complex topic. And then there's patterns, so like regular expressions and things like that. So we saw in the examples, bash scripts can be powerful. We can have interactive displays. We can use number crunching through expressions. We can automate things through bash scripting. And it's also very popular among DevOps developers. So I'm starting to get into DevOps a little bit. And as a DevOps admin, you actually use scripting a lot more than you would as a normal sysadmin. We do offer 2 courses for bash scripting. So we have the intro course, which is going to go over a lot more kind of these functions and the if-then statements, the while loops and things like that. So we spend a lot more time on each concept. And then we go into the more advanced intermediate stuff. So we'll talk about like arrays, dictionary definitions, some of those patterns and things like that. And then there's also through the codingbootcamps.com, we offer one-on-one private tutoring sessions. There's weekly, monthly plans for those. And those are nice because we have those self-paced classes. And you can play those videos and take your time on those, but you're not going to get the interaction like you are today with me and you. So these are nice because you can get that one-on-one sessions. All right. So
one question.
Yeah.
I always hear this word DevOps. What do they do?
So DevOps kind of has their hand in a little bit of everything. So a sysadmin is going to be working primarily with just a certain operating system and like just servers.
Okay.
Whereas DevOps guys are going to kind of have their hands in everything: networking, servers, the OS, storage, coding. They have things called CI/CD pipelines. So you put these codes into these pipelines, then it gets pushed out to different repos. So they just kind of touch everything. It's a kind of a jack of all trades position. Whereas with a sysadmin, they might be a little bit more specialized on certain things. Let me see if I can find, I had a really nice flow chart. I have it printed off. I'm gonna see if I can, let me get this thing out here, it's blocking my view. Let's see if I can find California DevOps flow chart. Can I explain things better? That's not the exact ones I was looking for. Okay. Yeah, here it is. This is the one. This is the one I like. It took me a little. There we go. Okay.
You have to know a couple of programming languages like Python, Ruby, and
yeah. So how this flow chart works is, as long as you know like one of these, you should be okay. I mean, it definitely helps to know all of them. But as long as you have at least one of the concepts down, you should be okay. And then as time goes on, you can start to learn the other one. So yeah, you want to start with learning a programming language. Python is a pretty popular one. Ruby is very kind of lackadaisical and forgiving on things, whereas Python is very structured. Everything you do has a certain way to do it. Ruby is less so, but it still has some structure to it. I don't know Node.js a whole lot, to be honest. There's also some of the older, there's some of the older languages like C, C++. Yeah. And like it says here, it doesn't matter which one you learn, just pick one and get some programming knowledge. Because once you learn one, a lot of them are kind of similar.
Okay.
And then understand different operating system concepts, so process management, threads and concurrency, sockets, input-output management, virtualization. If you pass the RxCSA, you'll learn a lot of these. A lot of these will be covered and you'll feel pretty comfortable with them. And then just learn about managing servers. So kind of typing in the terminal. Again, if you get your RxCSA, you're going to be pretty comfortable in the terminal. And things inside the terminal are learn bash scripting, which is a lot of stuff we went over today. Your text editors, which you're using VI, I use Vim. I don't know a lot of people that use Emacs. Nano's old school. That's a kind of OG stuff. PowerShell is Windows.
Yeah.
Mhm. And then you're also going to want to know text manipulation tools, sed, awk, grep. Grep is a very helpful one. You'll use that all the time in Linux and in the command terminal. Sort, you kind of use that sometimes. Cat, obviously, I used cat a ton today. So, just get familiar with all of these. Like I said, if you get that RxCSA, you're going to be pretty comfortable with all of this. All of this should be pretty familiar once you go through all that stuff. One of the operating systems. I don't know too many people that use Unix anymore. At IBM we do, but that's just because IBM is pretty old school and some of their servers still run on Unix. I can't see you actually running into Unix too often. It's gonna be Linux now. And then you said you're familiar with Windows, so you're probably good there. And you're learning Linux now, so it's definitely good to know both.
Mm-hmm.
And then you actually said you kind of came through some networking stuff, right?
Right.
Okay, so you may even know more about networking than I do. I didn't get to touch networking a whole lot at IBM. I know some of it, so it helps to know those concepts.
Mm-hmm.
And as a DevOps guy, I'm having to learn a lot more about networking now, especially with all our APIs and all the web pages we have set up.
Okay.
And then what is and how to set up like a reverse proxy, forward proxy, a load balancer. I mess with that a lot now, which is something I didn't used to do before, caching a server, firewalls. I'm learning about like Apache. We use a lot of Nginx now in my DevOps stuff. IIS, Tomcat. And then learning infrastructure as a code, so IIAS, or I'm sure as a code, IaaS. So things like containers. Docker is a very popular one. That's probably one to get familiar with. And then using automation tools like Ansible, that's a pretty popular one, especially now. That one's going to really take off. Chef and Puppet are also really popular ones. And then provisioning tools. I'm actually going to send you this link in chat. Because I have this flowchart printed off, and anytime I get bored or have some free time, I'll try and see if I can learn a little bit about some of these topics. Let's chat. Here. Freeze up on me. Hold on, Zoom's kind of bugging out on me right now. Well, while that's trying to load, we'll keep going through this. Where were we at? We were talking about infrastructure as code. Oh, yeah, so CI/CD stands for, I think it's constantly integrating, constantly developing. So basically, it's just you're doing code all day and then you're pushing it out and it might not work. So you bring it back and you tinker with it a little bit. So you're just constantly going back and forth with the code. Jenkins is going to be the most popular one for sure. I haven't really heard of all these other ones too much. But if it's outlined in yellow, that's going to be like the popular ones. Learn how to monitor software and infrastructure. Things like Nagios, that's super popular monitoring tool. As well as get familiar with logs. So most programs in Linux are going to have its own little log system. Elk, especially. And then you get to like your cloud provisioners, so like AWS, Azure, things like that. Get familiar with like their proprietary stuff. This isn't an exhaustive list by any means. There's definitely more to it than this, but this is like a good idea of kind of like all the different stuff you need to know as a DevOps guy.
Yeah.
which is a lot, believe me. I know looking at this, you're just like, holy hell. But just by taking that RxCSA, like you can get familiar with big chunks of this. Did chat finally. Still not gonna pull up for me. Is it on the other one? There it is. Okay. There we go. What were we? That's the end of our PowerPoint, wasn't it? Yeah. All right, cool. Oh, yeah, 120, so we got a little bit of time. Before I break open my RxCSA notes, are there any other questions you got about any of the bash scripting stuff or Linux or anything in general?
No, I'm pretty much good now. I learned a lot, because the main thing is knowing how the different forms of the bash script, the just the little details, because you have to be very detailed when it comes to this.
Yeah,
So,
Linux is picky. Yeah, you gotta have the right
Yeah.
spacing and things need to be in the right spots. Yep, it's super picky. There we go. All right, let me try to think of the best way to do this. I wonder, can I upload files to chat? Drive, Google Drive box. Won't let me just put a file in there. Or if I can put it in my drive and do it from there. We might try it that way. I'm going to sure we're on the right screen here. Oh yeah, that's right. This isn't my drive. Into my drive. Right. New docs. Right. You see my Word doc?
Yes.
Okay, perfect. So I'm just gonna do like a bulleted list of things you should probably focus on for the test.
Okay, fantastic.
And then I think it should let me put it in the chat. If not, you can just like type in your email and I can send it to you that way. Definitely know how to reset root password. I'll set up repos. Set up. And you said you're taking version 7, so we don't need to worry about video or Stratus.
No, put it there. Put it there.
Okay.
Put everything you can, everything you remember.
This is misleading. This isn't tuned. This is actually tune D. But this is like how you type it in on the terminal. So I'm just going to leave it like that. If you go through the material though, or like Google it, you'll see it. Networking is actually a pretty good chunk of it. So I would be familiar with like how to set an IP, set like a same, set a gateway. Server. There we go. What else? SE Linux. This is a nightmare, I'm not gonna lie. SE Linux is a pretty tough topic and there's a lot to it. This is something I missed on the test and that's okay. I never really like figured out how to get it working. So I was just trying to learn as much as you can about SE Linux. So NTP is a network transfer protocol. It's just basically how you set a clock on a server so it can keep time accurately. And you like synchronize it with a another server whose only purpose is to keep time, which is goofy, but it's kind of like your CMOS battery on your laptop. You gotta have the right time. User management, big part of it. So things like create a user, set up that's probably, I think that's just about everything you'll probably need to really study on and focus. ACLs are just access control lists. AutoFS is a way to automatically mount a file system when you log into a server for a specific user. That one will take some time to wrap your head around. Yeah, network transfer protocol. I'm going to, what was that called? It's called the Inmon, or let me open my can they'll teach you how to set up networking via like one-liner. It's just this like ridiculously long command. So I mean, it'll be like, just like command after command after command after command. It's just like this huge line. Or you can use, I think it's called nmon. Okay, apt. Okay, let me Google it before I just start installing stuff. Let's call it nmon. Oh no, that's for performance. Oh, it was NMTY maybe. Yeah, there we go. Awesome. Or you can do it this way, which is way easier. and you can edit all your connections and do it that way. So I think it's obviously way easier to do it this way than have to type all the commands. So let me write that on there too. That's installed on mine. It may not be default on yours, so you may have to install it. And I don't think it'll be installed on the test, so you probably have to install it there. Where is mine? There you go. Yeah. Video and Stratus. So that's just like a newer way to set up file systems. That's new to RHEL 8. So you have to look into how to do those. And then you also have to look how to do it the old way using LVM, which is Logical Volume Manager. You'll have to set up and enable repos, and then you'll have to know how to reset root password. I think this is on Google, so I feel okay saying this. But like if you can't do this, you're not even gonna be able to start the test.
Can't do what?
If you don't know how to reset the root password, like you won't even be able to start the test. Like you'll just be stuck there. So and I think that's pretty much, if you Google what the test is gonna be like, I'm pretty sure that's all over. So I feel okay saying that.
Yeah, I'm taking a course online, so I'm kind of familiar with almost everything you put there, but I think I'm gonna make the investment and get Red Hat subscription.
Okay.
You know, Red Hat has a course online that is pretty much how you get to qualify you to take the test. And it's like $5,000. Yeah.
It was like I said, I was luckily IBM had acquired Red Hat, and I was fortunate enough for them to give me a subscription, so I didn't have to pay for it. But it is expensive. But if you go through those labs, and you can do all those labs without having to look at your notes or look stuff up, and you can just do it and type it, you'll be fine for the exam.
Yeah, I think I'm gonna do that.
And with the subscription, I believe you can take 5 tests and you get 2 retries total.
Yeah.
So even if you don't pass it the first time, you'll know exactly what you need to know and like what you missed, and then you can really nail down what you weren't sure about, and you'll be fine the second time.
Right.
And then let me see this and see if I can put it in chat. If not, I just email it to you. Just got it right. Just see this. Right. Make me sign up. Okay. Yeah, you know what? Let's make this less complicated. Do you want to just throw your email in the chat and just email you that?
Yeah, for sure.
I just want me to like connect my Google Drive and log in and all that.
So those 2 courses in batch that you just mentioned, can you send me a list price and when they're being offered as well? Because I like to continue.
For sure. Let me send you that link as well.
Because I hate taking introductory course then walk away,
Right. Perfect. Yeah, let me write that down. I'll in that email, I'll send you the link to the website, those courses, and all that, all at the same time. Cool. All right, we actually got some time here still, so I'm going to open one of our. This guy out of the way. I thought I had it opened. me see if I can find some good examples in this. Check out some other things we can do. So on here, this will actually start getting into arrays and stuff, and I don't want to confuse you too much on that type of stuff. So let me see if we got some somewhat simple scripts on here. This is arrays. Oh, here we go. We can go over files and redirection. Or, well, you said you're familiar with redirects, right?
Yes, I am.
Oh, okay. Yeah, we'll skip that then. Yeah, pipes too. That's all it's redirects. Processes. So we already did that one. Yeah, it's using args. No one really uses args too much. That one too. Okay, let me break out my scripting book here. Let me see if there's an example. There. Sorry, give me 1 sec here. I'm just looking up other examples we can do for some of these scripts. Because we already did all the ones through there. I'm trying to come up with one off the top of my head, but then you're gonna have to see me, fumble through the logic of it. Make sure it actually works. So let me just look through my book here and see which ones actually work. This is way, let's turn it into leaves. Okay, so this is going to kind of look at, so we looked at the -GE, so we're going to kind of look at some of the other uses for those square brackets. So we'll call this one Vim, let's say, I don't know, less.sh. So we're going to go to insert mode, put in our hash plane. And we're going to set a variable here. We're going to set it equal to 10. We're going to say if, use a square bracket, variable in -LT, and this stands for less than, so it's less than 10. And I just realized why my other one didn't work. Let's put then right after this, but I needed to put it here. Then echo else echo so this is a simple if then else statement. So we're setting a variable, we're setting it equal to 10. Okay. We're saying if variable in is less than -LT 10, and we're encapsulating that with square brackets because we're using these here. We could also do the actual less than sign, but if we do that, we would need to use the parentheses instead. So we are using square brackets this time, -LT. So we're saying if n is less than 10, then echo it is a 1-digit number. Else, if it's false, echo it is a 2-digit number. In this case, 10 is equal to 10. But we're going to run it and we're going to see what happens. Right, quit. We'll have to make it executable. User plus x plus. And then we're going to go ahead and run it. There we go. It says it's a 2-digit number. So let's check out what happened there. So 10 is equal to 10. Therefore, it's not less than 10, which made this a false statement. Now, remember in these if statements, it has to be true in order for it to do this first part here. Since it wasn't true, it went to this other part here. If this is true, then do this, else do this. In this case, it was false, so else it went to this, and it just said it's a 2-digit number. So if we go to that script again and we alter it, we go ahead and make this n equal like 7. We save and quit out of that. Well, now n equals 7. So if n is less than 10, if 7 is less than 10, that's true, obviously, then it should echo this. So let's go and see. There you go. That's exactly what happened. So because 7 is less than 10, it made this whole statement here true. So therefore, it went to this first guy. If this is true, then do this, which is what it did. Now we can even take this a step further and do that special variable that we learned about. So the $1. Now we can input into it and it'll feed it into here. And we don't even have to come into the script and change it every time. We just give it an argument. So let me clear my screen real quick. God bless. So now we see our new script here. We're using that special variable, $1. We're going to run it. We're going to do .less.sh, and we're going to give it the number. We're just going to give it a ridiculous number. There you go. It is a 2-digit number. Obviously, it's bigger than a 2-digit number, but our script is not smart enough to handle, how big the number actually is, just because we give it a simple echo statement. So all it knows is that this is bigger than 10. And so it's defaulting to this echo statement. But it took our argument. This is the first argument we gave it, and it fed it into this variable here, in. And then it put it into there, and it ran this. Get out of here. And then it ran this statement. Oh, no, actually, that messed up. It should have ran this. If blank is less than 10. Oh, no, sorry. That's right. This is false, so default to that. Never mind.
So the first statement has to be true.
Yep.
And then if it's not true, then it goes to.
Yeah.
Okay, gotcha.
I confused myself there for a second. Yep. If it's not true, it goes to this else part of it, and it runs that part of code. And that is definitely not less than 10. We could even add a couple arguments there. So we could do 98, 5, 3, 4, 999, 700. And it's not going to matter because it's going to only take this first argument. Even though 3 and 4 is less than 10, it's still only taking this first argument because that's what we set it up to do. We can put multiple if statements in a script. We don't have to do just one. So I can set up another if statement here. So if, let me set up another variable actually before I do this. So we'll do n equals 1, and we'll say b, or $1 for first argument. We'll say b equals $2 for second argument. Then we're going to make a separate if statement. So if $b, and we'll say is greater than GT. And we'll just keep it simple. We'll say 10, square bracket, semicolon, then echo 1. Else echo in this statement feed. So we have two separate if then else statements here. And how this will work, it's still going to go line by line. So it's going to come here, it's going to see that we're using the bash shell. It's going to skip this line, there's nothing here. It sees the first variable here, which is n, and we're taking the first argument we give and putting it into n, and then it's going to take the second argument we give and it's going to put it into b. Then it's going to go through this first if then else statement. So if n is less than 10, so if variable n is less than 10, then run this, else run this, and then finish this if statement. Then it's going to skip this line because there's nothing there. Then it's going to look at the second if statement. It's going to say if variable b is greater than 10, then do this, else do this. That's going to close that statement out. So let's run that, see what happens. And I don't have to make this executable. It's the same file. It's already got executable rights on it. And we're going to do 98, and then we'll do 2. And then let me cat the file so we can see what I did on there. Okay. So let's look at our first less statement. So we took 98. My echo statements don't make sense. But it did work. So anyways, we took 98, threw that in here. 98 is less than 10. So this was a true statement. I mean, sorry, it was a false statement. So let's spit this out. It's a 2-digit number. That's what we see here. And then we took 2, threw that in here. 2 is not greater than 10, so it's a false statement. So let's spit this out. And like I said, my echo statement just doesn't make sense. Obviously, 2 isn't a 2-digit number, but that's just because I kind of had a brain fart and should have made that a different echo statement. What I should have said is if it's less than 10, it's a 1-digit number. What should I put? Yeah, now that actually makes more sense because we're doing greater than. All right, we're going to look at another if-then statement. We will name this one or.sh. Insert on my hash name. We're going to look at something called or here. Okay. We're going to make it interactive. Let's do echo enter any. We're going to use that read command we learned. Read. And we're just going to throw it in a variable in. You go ahead and set up an if statement. We're going to put double brackets here with parentheses. We're going to say $in. So if variable in is equal -eq to 15, or is a double pipe. So 2 pipes like this, pipe is just above your enter key. See 2 pipes like this means or variable in is equal to 45. Double square bracket. Then go. Or means here in 1 second. In. Else you lost the game. So it's like a number guessing game. Okay. Oops. Close out our if-then statement. Okay. So what or means, so we talked about and how when we do and the double ampersand sign, this has to be equal. Oops. And this has to be equal in order for the whole statement to be true. That's not the case for or. With or, this can be true or true, and the whole statement will be true. So as long as one part of this is true, it'll make the whole statement true. Okay. So this is going to be an interactive prompt again. It's going to echo enter any number. It's going to want us to put a number in. Whatever number we put in here, it's going to store it in the variable in. And then it's going to throw it in our if statement here. Okay. So I'm going to do a right quit. I'm going to make that executable. I named it or. So chmod user plus executable or.sh. And I'm going to run that script. And if you need me to slow down, just let me know. And now it wants me to type in a number. I should have cat that file before I did that, but that's okay. So I'm going to type in, let's just say 22. You lost the game. So let's look at what happened. So it went ahead, it ran our echo statement, then it ran our read command. I put in a number, which was 22. So it stored it in n. So now n got thrown into here. Well, is n equal to 15? No. Is n equal to 45? No. So both statements were false. So we went to this part here. It wasn't true,
Right.
so it did not run this. So instead it ran this. Okay. So let's run it again. This time I'm gonna put 15. All right, cool. This time I won the game. So I put in 15, so it ran this echo statement. It threw 15. So then it put it in here. 15 is definitely 15, so true. 15 is not equal to 45, so this part's false. But since this part was true, the whole statement true. Therefore,
Right.
if this is true, then it ran this.
Okay.
We can even tinker with that more. We can do this again. .sh. I could even do if n is if n is greater than 15, then 45. So now, as long as I guess a number in between these two, it should tell me that I won the game. So I'm gonna guess a number outside of that. So I'm gonna say 153. Enter. You won the game because yeah, my logic's off there. That's why. I would have to actually set up some other condition. Yeah, about that a little bit. Okay, so what's going on here? My logic's just off. The script ran as it should have. I would have to set up some other conditions there. Obviously 153 is definitely greater than 15, but it's not less than 45, but that doesn't matter. It's not gonna set it to where it has to be in between these two. It just has to be either greater than that or less than this. So that's actually my fault. I would have to sit here and think about how to set up a range in between the two. Yeah, that would take me a second to think about that. So it was still right. It still did what it was supposed to because it was greater than that. Yeah, I don't think I want to get into case and else if statements because those are a little bit more kind of in depth. Okay. That's probably good with those. Is there any questions you got, or maybe any other examples you want to go over still?
No, I'm good. I'm good.
Trying to find my PowerPoint here. Yeah, because we only have like 7 examples in here, which is fine. That's probably a good start on scripting. So if there's any of these topics that you still want to go over a little bit more, we can. Otherwise, we're done pretty early, but typically we usually have a few more students show up and, there's more questions and things
I
like
was
that.
happy for the
So
one-on-one.
yeah, you got a little bit more extra attention.
Yeah.
Okay. Is there anything outside of Bash script you want to talk about as far as the Linux courses or any questions you got about the RHCSA stuff?
Well, you gave me a great outline on the RACH course certification, and you're sending me some links to
Yeah.
for some more Bash courses. So that's a great start.
Yeah. Okay. Cool. Well,
All
yeah,
right.
we are done, kind of decently early, but kind of to be expected. Like I said, we usually have a couple more students, so have to go a little bit slower back up. So that's fine. If there's nothing else, man, go and kind of let that stew in your brain. I'm sure it's kind of feeling like soup right now. So,
Thank you, Kevin. Appreciate your help
yeah.
and appreciate you.
Yeah, no, thank you for showing up, man. It was fun. I enjoy teaching this stuff. I'll send you that email if you got any questions. In the meantime, you can always just email me back with any questions you got.
Okay. Fantastic. Thanks again, okay?
Yeah, no
Have
problem, man. You have a good day.
All right, you too.
See you, man.
Bye.
Email.